Okay, hi everyone. We might get started. Oh, there are a couple more people coming. So to get started, firstly, in the spirit of reconciliation, we'd like to acknowledge the traditional custodians of country throughout Australia and their deep connection to land, sea and country. We pay our respects to their elders past, present and emerging, and we extend that respect to all Aboriginal and Torres Strait Islanders. Now, kicking off today, we've got Chris Doropoulos with our plenary session. Thanks, Chris.
Morning everyone, thanks for joining this session. In the spirit of sharing something about myself, I grew up snorkeling on the beaches of Perth, Medham's Pool mainly, and then kind of thought I'd always be a wetland ecologist until I jumped in at Ningaloo Reef and saw corals for the first time and quickly got my diving ticket and moved to coral reef ecology. Also in the spirit of sharing something, I put in a very niche kind of abstract, but then was given a keynote, so my talk's quite different to what I initially thought I was doing. I'd also like to begin by acknowledging the traditional owners of the lands that we're meeting today, elders past, present and emerging, and particularly in the RAP space as well, to all the traditional sea country that we work on. So to begin, I'm going to talk about one of the projects within EcoRAP specifically, and it's really kind of nailing, or trying to understand many of the gaps in the limitations to early coral recovery. We're a team between CSIRO and UQ, involving PhD students, postdocs and scientists, and we're about 22 people. Okay, so the integrity of coastal marine systems across the world has been degrading, and that's inclusive of coral reefs. These are many of the kind of reefs that we've been working in the last 3 years, and you know, Roger fortunately has introduced many of the processes around resilience that kind of forms the introduction of my talk. As we've all seen, we're currently in the middle of a mass coral bleaching event, and so once we get into this kind of state, what are the sorts of processes that can help recovery? So while ameliorating stresses of rest decline, boosting the resilience of coastal marine ecosystems relies extensively on ecological restoration. And that's one of our hopes, is that we can use restoration to help with resilience. So if we think about a hysteresis curve, we have positive and negative drivers, and they'll keep the system into states of, you know, coral dominated versus not dominated states. And there are different components that can push us from or keep us within those positive states, and that's what we're aiming for. And overcoming recruitment limitation is one of those major drivers that can help keep a system in a state that has positive reinforcing drivers. So what do we know about coral recruitment ecology? We can break it down into stage-specific limitations that drive recovery, all the way beginning at reproduction to larval dispersal and then return back onto the reef, settlement and early growth and survival. And so we can break this down into stage-specific processes. Now we know that acute stresses really typically reduce fecundity of most corals on the reef, the survivors that is. So we have a lot less output, and what does get output is often not functioning very well. What do we know about fertilisation? Well, latent effects, they likely cause decreases in fertilisation, and that can be related to spacing of individuals, so that maybe the coral and sperm don't meet each other very well, but it also can be like, well, maybe those sperm aren't functioning very well for that year or a few years afterwards. We also know that chronic and latent effects definitely impact larval development and likely dispersal and reef connectivity as well. Now, predators and competitors influence larval supply and settlement, and likely the relationship between those. Post-settlement predation and competition are severe limitations to post-settlement survival. Now, once we're getting through to the larger size of recruits and then growing into mature adults, environmental gradients can influence the demographic rates that occur on reefs. But I would argue that across 4 of these processes, we actually have very limited understanding, and that's what Eco2 is being challenged with trying to address. We basically had no field attempts to validate alley effect theory. There's very few attempts to validate any connectivity models, and there's limited knowledge on presumed supply-settlement relationships. And I think there's no attempts to quantify the effect of environmental gradients on juvenile coral demographics, but there might be some that I'm not kind of aware of. So that's the overview of the talk. The beginning of the talk is we'll ask the questions, what are the critical densities of corals that are required to establish functional reproduction on a reef? And ask the question, can connectivity models capture larval supply at settlement that is at scales that are relevant to restoration operationally? And what are the taxon-specific sizes that may optimise early coral survival across environmental gradients to assist with densities of deployments on reefs? So this is going to be a little bit of a showcase because there's many people that have kind of contributed to this. So first off, Elizabeth Bucheri is one of our PhD students, and she's been looking a lot at sperm limitation effects, and one of these is looking at the influence of wind on embryogenesis and larval survival. And she'd set up some pretty cool experiments using recirculating flumes driven by this wind turbulence that was downscaled from observations throughout the GBR at spawning times. This work was done at CSIM, and what she found is that fertilisation is inhibited by high wind and long exposures. She did this with 4 coral taxa. That also, well, as you increase this turbulence, we get more deformed, fragmented and damaged embryos. And what does that mean afterwards? Well, actually, larval survival is significantly higher for those intact embryos. So we understand from this piece of Liz's work that increased turbulence reduces the production of coral larvae by disrupting fertilisation and larval development. So we need to think about, well, what does that mean for outplanting in different kind of environmental settings? If you didn't see Pete's talk yesterday on our postdoc Jared Ricardo's work, there's a little snapshot about that. And this is where we ask, well, what are the adult patch characteristics required to have a functional reef in terms of reproduction? So for that work, we've conducted 5 manipulative field experiments manipulating coral densities out on reefs using small and low density patches. And what our field experiment showed, is that they resulted in low fertilisation success, demonstrating that alley effects do exist on a reef. So this has previously only been modelled. We then use this information plus a whole other bunch of parameters that have been collected in the lab, as well as some dispersal parameters out on the reef. And Jared put together this model. It was improved from the Teo and Todd model. And as you can see, we're getting this great match between our field validation experiment and what the model's producing. So what we can then do with this is we can ask the question, well, what are those colony sizes and spacings that we need to have some minimal kind of reproduction output? And, you know, Jared's produced some really nice rules here that, you know, we need partners within at least 5 metres of each other to have something meaningful for functional reproduction. And that kind of goes to about 9 average size colonies to achieve at least 10% reproduction. But, you know, we want to get higher than that. So colonies can be spaced 2.5 metres apart, and they might be getting to 40% fertilisation, for example. So this is something that managers can use, or we can use in our decision making on outplanting on reefs. So Robert's been doing some work on ground truthing connectivity models, and we've done a series of experiments to understand, well, what's the demographic influx of coral larvae of spat onto reefs over different spawning events. So to do that, we've done this in the Cap Bunkers, but also in the Palm Island region. We set up these stations where we sample coral larvae in the plankton before and during spawning events every day spatially. We set up tiles as well just to understand cumulative settlement just after that spawning period, just for a couple of weeks, so the very early settlement stage. Do some really high connectivity modelling. We're getting some really nice spatial patterns, which between these three events, the concentration of influx is agreeing between events. And what are we seeing in terms of our predictive ability? Well, when we look between model observations of settlement and what we observed, we're getting a significant prediction, but there is high variance around that. So there's some caution in what we can can predict at such small scale. So we're talking about a kilometre here. But then when we only use our observational data and we match up supply with settlement, we see we get a significant relationship, and a lot of that variance is quite well explained as well. So we can use tiles to infer something about the supply of larvae is what this is suggesting. Now Devon's been looking at some work around size-based survival of juvenile coral outplants. So this is more looking at asexual fragmentation and rules that we can utilise. She's been deploying fragments at different kind of orientations and different species. This one's been going for about 15 months now, and she monitors that every 3 months. Before February, what we were seeing is between an Acropora and Platygyra is we're getting higher survival with the Acropora, but that survival is decreasing with increasing size above 25 millimetres for these fragments, and there's no real effect of the orientation here. Now, in terms of bleaching incidents, the Platygyra are bleaching regardless of their kind of size, but what we're seeing with the Acropora is there's actually a size escape, so anything smaller than 25 millimetres hasn't bleached, but then beyond that size we're getting about a 50% bleaching incidence. So, and Devon's going back to herons soon to actually then do her mortality assessments. Now I'd just like to acknowledge the co-authors for this work, which is based on juvenile demographics across the Great Barrier Reef, and this fits in with the reference reef kind of design that we've utilised, the eco-wrap. Hopefully you saw that in Katarina's talk yesterday. Our major objectives is to assess variation in juvenile coral demographics across coral groups and environmental gradients, and then to provide guidance on the sizes and densities of corals that maximise probabilities of survival following outplanting. And this knowledge can provide baseline counterfactual information and can also be utilised by the modellers. So how do we do that? Well, we've utilised the spatial design of EcoWrap, which goes from the far south to the far north and into the Torres Straits. We have nest sites and quadrats in a nested style design. And we've got 2 transitions because we've got 3 data points at this point in time. We only work in the 5-metre depth profile. So we define juvenile corals for this exercise as less than 40 millimetres. It's operational and it's kind of a classic size. And we're kind of using 5 major groups, and we're following about 2,500 individuals. How do we do it? Well, Katarina writes this on a data sheet underwater in T1, like T0 when we set it up, and someone has to transcribe that later. And then we actually take an image and we process that using Reef Cloud to get cover at that kind of scale, and also to give us an image here that we can work with. And then that gets traced onto a map, and we grid that up as well. So now we can look at density dependent things too. So this is in this kind of database. And then we go back to those plots. And you can start seeing things grow and die and appear, and then we create those mats, and then we can create our database from that. Some of the other data is about environmental parameters. Mariana's done all of this work, and you can see we've got a clear environmental gradient here with temperature going from south to north, and I think it's about 4 to 5 degrees there. And then we have other parameters that we can look at, and that's things such as turbidity, which is vertical attenuation, and you can see there's some areas of the reef that are more turbid than others, and the upwelling down south there's a clear signal of the chlorophyll A there. We can put this into an ordination, and when we do that, we end up with 3 pretty, I would call those quite distinct groups, where we've got this kind of central northern cluster Is there a laser pointer? Do I dare? Up here, which is anything from the central reefs all the way to Torres Straits. Then we've got the Cap Bunkers out here, so they're the reefs in the far south, offshore, and then we've got the Keppel Islands, which are the reefs in the far south, but inshore. And the temperature gradients driving this grouping at the top, this separation, and then this is chlorophyll A, and this is turbidity. Okay, so I'm aware I don't have much time left, so I'm going to breeze through these. So just some data on coral juvenile density is that, unsurprisingly, Acropora are the dominant corals in these fixed plots throughout most of the reefs, apart from those in the very far north. And we do get some kind of community separation there, where the offshore northern reefs and the Torres Straits, in an ordination, do separate out. And if we're thinking about what densities we're looking for, well, total densities here, we're getting anything up to 26 juveniles per metre square, or as low as 15 juveniles per metre square. So healthy reef systems, which we've been working in the last 3 years, maybe these are the kind of densities that we need to be thinking about. We look at recruitment. We've got the highest in Acropora, unsurprisingly. And when we look at mortality, we see the similar story. When we think about this thing called turnover, and it's just, well, what's the net gain or loss? You can see that it's generally around 1 to 2 individuals per metre square per year. We've got a couple of hotspots there with, loads of Acropora coming in still in the Cap Bunkers, and loads of parietes coming in the Torres Straits. I think what's interesting is to think about, well, when we deploy, it might not be a single deployment event on a reef. We might have to do sequential deployments rather than just one event and assume that things are going to be cool thereafter. So some size-based data now. Unsurprisingly, this is growth. We get positive relationships with Acropora and Posilopora. And then these kind of neutral or slightly negative size-based growth relationships with parietes and merillinids. In terms of environmental parameters, there was no positive effects or negative effects of anything apart from flow, where we get a slight positive effect of flow on growth rates, which has been shown in other studies as well. We think about survival, we get this generic function, size-based survival. As things get bigger, they get smaller. And so the minimum size I think we're working there is about 3 millimetres, and it's going up to 40 millimetres. And we find that across corals and other benthic invertebrates. But if we think about what's happening across clusters, we get this thing that's happening at the Palm Islands, which is kind of not, which is this neutral kind of relationship where size is an increasing survival in our corals on the reef. But you can also see that palms have a higher general survival than all of the other reefs as well. The Keppels have this negative relationship, but that's data to porphyrit. So, and you can see there's huge variance around that. So I would take that with a grain of salt. Interesting, with temperature, we get positive and negative relationships. So we get a negative relationship with the Acropora survival as temperature increases. We get positive relationships with the merillinids and the parietes, and then we get these temperature-independent relationships with the two other taxa. Remember, this is not any acute conditions. This is only that kind of chronic temperature gradient that is found naturally on the GBR. So what does this mean for restoration decisions? Well, size and early growth and their relationships with survival thresholds are really important to kind of keep in mind with outplanting, and that depends on where that is occurring. So, survival generally increases with size, but not necessarily for outplanted fragments, and there's, some small size escapes potentially, which are occurring with bleaching, which, is a general rule of thumb as well. And now we think about, well, how many colonies may we need on a reef? If we're doing outplanting and adults that are spawning, need to be closer than 5 metres to each other to have anything of some kind of functional reproduction of that reef. And so as things like wind turbulence increase, we need those things coming closer together as well. So depending on the environmental setting, we have to think about different kinds of clustering. And finally, connectivity models, we need to make sure that when we're operational decision making, that scales need to match, and our trust in in what they can do needs to be taken into consideration. And so, you know, at larger scales, they're doing really well. As we get finer, they're sometimes doing well. And, you know, when we get to that really fine operational scale, we'll probably need blends between models and field data, unsurprisingly. I'd just like to acknowledge the EcoRap leadership team, the EcoRap 2 team, and like the massive EcoRap team that we've been working with. The managing entity, GBRF, and the AIMS IP team, who have facilitated a lot of our free, prior and informed consent, all the stations we've been working with, and the Dargel Land and Sea Rangers, who we've had on all of our spawning events, and it's been a cool journey. Thank you, everyone.
Thank you, Chris. That was an absolutely perfectly orchestrated 20-minute talk. You had 5 seconds to go, so good job. Do we have any questions for Chris?
Thanks, Chris. Awesome work that you guys are doing. On the spacings of the reproductive colonies versus the occurrence of settlement, have you been looking at how those things correlate across the different coral families or genuses, or have you mostly been doing the Acropora work for the adult spacings?
Yeah, right. So I think if I interpret your question, we could think about, well, in our juvenile demographic plots, what are the actual spacings in those relative to what kind of these rules about the functional reproduction? We haven't done that yet. This kind of analysis that I presented on the juvenile demographics is, you know, I've kind of done that over the last month, and it's such a rich data set that I think that's a very worthwhile thing to do. I think also with the larger orthomosaics that we have in EcoRap, and you know, maybe Renata's going to talk about those later, you know, a really obvious thing is to utilise those and to see, well, what are the spacings of species in those, and what does that mean related to our kind of reproduction alley effect modelling. One thing I will say with the juvenile plots is we can't get to species level. So you saw that there's broad groups, and you know, if you've ever looked at a 1 centimetre Acropora, they all look the same. If we track them for long enough, we might be able to get them into morphospecies, but you know, I think it needs a geneticist to get it to our species. So, yeah.
Thanks, Chris. Great work. With regards to density-dependent fertilization, that's got real implications for rare species and has got real implications for the future of coral reefs as the densities are slowly declining. Do we need to start switching from thinking about density dependence to clumping?
To what, sorry?
Clumping. I mean, the distribution of species. Especially with deployments, if we are deploying, we don't want to compromise one species over another by increasing the density of one species at the expense of others. Does deployment need to think switching to clustering colonies in clumps and bringing rare species together in order to give them a fighting chance to continue into the future? So it's not the mean really density that matters any longer, but it's the spatial distribution.
I think I'd ask first, why is the with a rare species, if it's naturally found spread apart, like, well, why is it rare? I think would be the first question, and you know, do rare species kind of reproduce in what like we understand with like these really common Acropora that we've been working with? Because you know, our models have been parameterized from tenuous, like Acropora tenuous, Acropora digitifera, and Acropora hyacinthus. So, you know, really common, functionally kind of typical corals. But, you know, maybe the model would actually differ with a rare species. So I think we'd have to do some fundamental biology first, and then depending on that, we may have to then think about, clumping much more and having less spread.
So if I can talk on that, I'm working in Kiribati where that Acropora hyacinthus is extinct on many atolls. Or it'd be one colony or two colonies. There's no reproduction going on. So what you're learning here is extremely relevant to the front line of collapse, where we must get those corals back together again, or there's no recovery. And so this is extremely relevant to what we're doing. That's what we're actually doing, is bringing them back together into clumps.
Yeah, so I think it's a safe option to have a high density clump, but you're also increasing your risk that if you have a disturbance and they're all in that one clump and that disturbance hits that clump, you actually then have no resources outside of that clump. So, it's like a cost benefit exercise in that sense as well. So, yeah.
Hi, thanks. Just picking up from that, it's also very relevant to the rear guard of collapse, so to speak. So I'm come here from Florida, and in Florida, you could argue that relatively speaking, all of our coral species are rare now, but they weren't formerly rare. So your point about, why did they become rare? You could consider these to be formerly common species that are now becoming rare, and Florida's begun to do exactly what you've suggested, which is to clump corals together in what we call spawning hubs to try to increase the chance of them surviving. Unfortunately, there's these other effects that then hit those corals, for example, susceptibility to disease that is then hitting them because we put them together in these sort of highly dense aggregations. So, yeah, great talk, but definitely relevant to lots of different places around the world. I guess that's not really a question.
Time for one more question.
Nice comment.
Hi, thanks. Bit of a change in direction, but just with the modelling, so presumably where you find better survival of recruits, better survival of juveniles, you're going to have better recruitment anyway. So if you're planning an intervention and you've got this thing of the best place to plant is where presumably the best place natural recruitment has already got the best chance, how do the models fit with like how you plan an intervention based on you really want to help areas that aren't helping themselves?
Sorry, so can you repeat your question?
Yeah. No.
You can't remember it either.
It's basically, so we do a lot of coral planting. We've done it since 2018, but the issue is where it's most effective to spend limited resources. So trying not to plant corals where the natural recruitment is occurring anyway, and they seem to line up. The places where you're going to get best survivorship is where the substrate conditions best suit natural recovery anyway, and you may not be producing a big environmental benefit. So how does the modelling, say, help pick sites, and how do you factor in that consideration of best utilising your available resources?
Yeah, I think I'd ask the question first, well, why aren't those areas naturally recovering, whereas others have all of this natural recruitment there? And if it's something like, if it's a predator that's killing everything in those areas where corals aren't naturally recruiting.
This isn't a time scale where you haven't actually figured out. Like say you have an impact. Sorry. This is within a certain time scale. Like say, for example, now you've got an impact. You wait a certain amount of time before you decide whether to intervene or not. But you really want to be intervening at areas where there's not enough natural recovery. But how can you figure out, like, how long do you have to wait? So far, we've waited, say, 8 years since 2016. We've got sites that are 200 metres apart. One's recovered really well, the others hasn't recovered very well at all. How do you actually use this information about juvenile survival to help decide what to do and where to do it? You want me to be more concise?
Yeah, no. I think, it might not, like the juvenile survival, we need to understand why they're not surviving there. Is it competition? Is it sediment smothering? Is it predation? So we need to kind of understand, or is it something environmental? Is it, super bad water quality? Although you did say it's 200 metres apart, so I doubt it. So there might be something some ecological interaction that's occurring there that might be restricting the survival of those colonies. But I think without diagnosing that, and if you only use, say, a size escape rule, well, if you outplant bigger ones, they might survive better. But if there's a lot of corallivellas there, they're probably not going to survive very well if you put out bigger ones, because they're like pop sticks out in a desert. And that's when you would be better putting out smaller ones so they have a chance to kind of establish themselves and grow before they get hit by a predator. On the other hand, if there's a lot of competition and you put out a small coral, they might get overgrown quickly. So it's kind of a trade-off, and we need to understand the strengths of these ecological interactions to really understand, I mean, it's just, yeah, to really understand what the best strategy is going to be. Sorry, I mean, that's probably not a very satisfying question, but I don't think it's a simple problem.
I might talk to you afterwards as well,
Yeah,
if possible.
no worries.
Thanks.
Sorry. I think that's all we've got time for, so thank you very much, Chris. Next, I'd like to introduce Matt Curnock.
This will be a brief departure from ecological intelligence. So thanks for the opportunity to present this work here today. I acknowledge and pay my respects to the traditional owners of this land and the surrounding country where I grew up. So I'm Matt Curnock from CSIRO. I was born in Cairns here in Yidinji country. I'm a social scientist at CSIRO and based in Townsville. I'd also like to acknowledge the partners and co-authors of this presentation, which arises from several years of work and learning from each other. This is a group of dedicated and passionate people who care about the reef and what we can do by working together to help it in a time of need. And on their behalf, I thank the Gungandji people, the traditional owners in whose sea country our pilot study took place. So, as most of you know well, the Great Barrier Reef is a very large and complex system, and collectively, we're in a race against time to build resilience in the face of profound threats. You may also know that the Reef Restoration and Adaptation Program, RRAP, to date, has been an R&D program not intended to deliver reef-wide restoration, but to design and test the tools and methods that can be implemented at larger scales in partnership with others, and thereby foster a reef restoration and adaptation industry. Achieving that is no small task, and it's clear that marine science and engineering alone won't make it happen. Reef communities, traditional owners and industry sectors all have an important role to play and are already innovating and delivering restoration and monitoring at local scales. And as new technologies are developed and tested, we need to consider the social risks and build opportunities for partners and communities and create pathways towards an equitable and sustainable future with a healthy reef and healthy people. So what is collaborative monitoring? Well, very simply, it's a model to deliver monitoring that helps to evaluate a field trial. And collaborative in our case means local partners working alongside RRAP scientists. By design, it brings together diverse partners to monitor and share knowledge while building capacity and opportunities for future benefits. And this model and our pilot study are just one of a series of social R&D trials that have occurred over the last several years. Under the RRAP sub-program known as Best Practice Traditional Owner and Stakeholder Engagement, and some of my colleagues are presenting other case studies in different themes at this symposium. So the broad aims of collaborative monitoring include building and growing partnerships, trust and local capacity that can underpin future initiatives at larger scales. And it also has the potential to make restoration and monitoring more cost-effective by harnessing local capabilities and expertise. For our pilot activity, our main objective was to design, implement and evaluate a proof of concept model that uses local expertise, generates local benefits and enhances the R&D and deployment outcomes for RRAP. And some of the principles underpinning the pilot study included it being locally led and coordinated, co-designing the objectives and work plan with partners and traditional owners, multi-way knowledge sharing and information transparency, building lasting capacity, so training the trainers, shared ownership of data, outputs and outcomes, and to monitor, evaluate and share what we've learned. Now, for full disclosure, we didn't do any of these things perfectly. Some things worked well, some didn't, but the main point was to learn from our efforts to help guide future initiatives. We chose Moore Reef as the location of our pilot study because it's one of the most visited reefs for tourism on the GBR, so there's high visibility and accessibility to local partners and the wider public. And there are several ongoing stewardship initiatives there with lots of valuable local knowledge and expertise to draw on. We also sought mutual benefits by partnering with the Cairns Port Douglas Reef Hub, which was newly formed when we started, and they facilitated our connections with partners and delivered a range of activities such as training, workshops and the monitoring. And this helped us to connect. They also helped us to connect with the traditional owners of the sea country in which we worked, and we were fortunate to have members of the Gungandji Land and Sea Country Rangers take part in our workshop and subsequent activities. So what did we monitor? So you might have seen these ceramic coral seeding devices before, engineered by AIMS and used by the RRAP Coral Aquaculture and Deployment team, who are talking about them at this symposium. So the devices hold and protect baby corals that are spawned in the AIMS CSIM and settled onto those tiles. In our experiment, the devices were deployed onto coral rubble in 6 experimental plots close to the Reef Magic and Sunlover pontoons at Moore Reef. So this made them easy to access and allowed local partners to monitor them quarterly after their deployment in January 23. But there was quite a bit of work that preceded that deployment. Where's the come on button? Right, and that included engagement with local partners and traditional owners and establishing local coordinators. So Abby Scott and Katie Chartrand, who also coordinated the Cairns and Port Douglas Reef Hub. So we co-developed objectives with the partners in a workshop in April 22, and following that was the development of monitoring protocols, training and site selection prior to deployment. And to evaluate social aspects of the collaborative model, I had periodic interviews with partners to understand what was working and where to improve. And we're still working through our evaluation, but I can share some of the key things we've learned so far. But firstly, these were the goals of our in-water experiment. 1, to understand natural coral recruitment at the rubble sites. 2, to understand the performance of the seeding devices in those habitats. Then to use those learnings to inform future deployments and to contribute to a larger study on the survivorship of corals on seeding devices. We also had 4 social R&D goals. A, to improve engagement between local partners and RRAP scientists. B, to build a shared understanding of the risks and benefits of this type of restoration, and then thereby enhance local capacity to sustain and scale up future collaborative initiatives. And D, to create local partner benefits and identify pathways to future benefits. We also had an opportunity, and took it, to monitor visitor perceptions of assisted coral recovery devices, so ACR devices, near the tourism facilities. And with the help of the hub, we engaged with a few more partners in the wider Cairns Port Douglas region who helped to survey their guests, who saw several different types of devices in the water. And those partners are co-authors of a manuscript that we'll be submitting to a journal quite soon. I'm going to jump straight into our key findings right now, starting with a sneak preview of what we found from that baseline visitor survey. So, from a survey of 708 reef visitors aboard 5 different vessels that visited 8 reef sites in September last year, half of those visitors saw at least one of 3 different types of ACR devices, including our coral seeding devices. So when surveyed on their boat trip home, they provided ratings on a scale of 1 to 10, low to high, about their reef trip satisfaction, the aesthetic beauty of the reef site, their overall concern about the future health of the reef, and their concern about the use of these types of devices on the reef. So using a series of regressions, we could then see what factors were associated with their ratings. And first, we found that seeing the devices had no effect on visitors' satisfaction with their day trip to the reef. Second, the devices had no effect on visitors' perceptions of the visual beauty of the sites they visited. Third, seeing the devices had no effect on visitors' concerns about the future health of the reef, though most were already very concerned. But fourthly, seeing the devices did have one significant effect. People who saw them gave a lower rating about their concern for the use of such devices on the reef. Those concerns were relatively low overall, but seeing the devices firsthand seemed to further reduce those concerns. And there was no significant difference in ratings between the 3 device types. So moving on to our in-water experiment, much of the data is still being analysed, but we've learned a few important things. So related to our third goal, we learned that there are important aesthetic and amenity considerations for deployments near tourism sites. This feedback didn't come from our visitor survey, but from tourism partners who care a great deal about the presentation of their sites and the different activities that occur around them. We also learned that data quality from the monitoring is influenced by the site depth and substrate, and that ongoing training is a key part of successful collaborative monitoring. So as with every organisation, we need to manage for a turnover of personnel. And for future collaboration with tourism partners, we need to co-design educational material that can help guides explain the science and the rationale behind these devices, and we expect that this will enhance the visitor experience. Related to our fourth goal, we did contribute some important knowledge about limits associated with handling coral recruits. So what that means is our baby corals didn't survive the initial deployment. That was a real bummer, but an incredibly important lesson that's been taken on board by our AIMS partners for subsequent deployments. Arguably, the most important lessons of this pilot have emerged from our social R&D. So goals A and B are where we've succeeded most. So we've improved engagement between RRAP and local partners. We've identified shared visions and objectives, and we've identified ways to improve collaborations in the future. We've also built a shared understanding of risks and benefits from these types of initiatives. Communication is something we can all improve on. Early, frequent discussions are critical for setting achievable goals and managing everyone's expectations. We've learned how partner motivations and capabilities vary, and we need to allow different partners to contribute in different ways that leverage their strengths while investing more time and effort to build collective capacity. For example, traditional owners can lead components of work that address their own objectives and deliver benefits to their community and then to other partners. Training opportunities are highly valued, and our partners have already applied new skills they've learned in other areas. And more training and co-design training activities will be vital to the success of future initiatives. Our pilot activity benefited also from a lot of in-kind contributions from partners, including skilled labour and time and access to sites and facilities. So we're really grateful for that support, but we know we can't take in-kind contributions for granted. There must be an exchange of benefits. In some cases, remuneration is necessary, but that's not the main incentive for most local partners. So non-monetary benefits are more important, and these can include the transfer of knowledge and skills, and giving recognition and visibility to partners' work, their capabilities and the niche they provide. And then there's co-ownership of achievements from the collaborative work. So in terms of high-level outcomes, some lessons from this pilot have drawn from and informed the development of other local monitoring and capacity building activities in the region that are being delivered by the Cairns Port Douglas Reef Hub. Some of our insights can help to inform future data sharing practices or agreements between RRAP and local partners. The pilot has helped to identify and begin to unpack diverse local business models that can support partnerships in future RRAP deployments, and this work is being built on by my CSIRO colleague Taryn Kong. And insights from our visitor study have helped to identify benefits associated with publicly visible demonstration sites and the value of related interpretation for visitors. So in conclusion, our pilot activity has only scratched the surface of what collaborative models can achieve, but we are hopeful that our learnings will help to guide future initiatives, and our partners, including traditional owners, local tourism operators, restoration practitioners and scientists, are all committed to building on what we've started and working together in complementary ways to continue to grow local capabilities and benefits. Thanks very much for listening.
Thanks, Matt. Do we have any questions for Matt?
Hi, Matt. Great talk. This is not a question, it's an apology for that strange burping sound from my bottle halfway through your talk. But no, very interesting stuff. Thank you.
Oh, thanks.
How can I get that to you? My arms aren't that long.
Thanks, Matt. That was a really great talk. I'm really not in this space very much. I look more at chemical control of COTS, so I'm just putting that caveat out here. I also work with microplastics, and what I'm particularly interested in is we're seeing a lot of this restoration push, and a lot of, we've got tourism operators and citizen scientists getting involved. And I'm just wondering, what is the perception around plastics and the use of plastics in some of these restoration processes? And is that something that comes out in these surveys that you're doing of your visitors?
That is a very good question, and I would think that there's a pretty high level of awareness in the community around plastic pollution. It's not something that came up directly in our study. but I do see that being a significant concern in other monitoring around, social monitoring around the reef. So I can't answer that question directly, but I just acknowledge that it's an important issue for public perceptions.
Thank you. In the interest of time, we might have to move on. Thank you, Matt. Next, we have Manuel Gonzalez-Rivero.
Hi, everyone. Thanks for staying for the talk. Today, just want to talk a little bit about moving beyond reporting on coral cover and trying to bring together a little more the different aspects of the ecology of the reef that we monitor, but it's very challenging to communicate and to use all together to be able to advise where we're headed in terms of management actions. I hope I can press the right buttons. First, I just want to acknowledge the traditional owners where we meet, but also for those countries where we all work at AIMS and also part of the BRAP program. I want to pay my respects to the elders, past, present, and emerging for tomorrow. And I also want to acknowledge that this is a big team effort. It took us about 2 years to really think a little bit about it. But what I want to present to you is something quite simple, because of time constraints. But there's a lot behind that this amazing group of people contributed to make it happen. It was also a work guided by the Reef Authority to actually trying to implement the framework that we're trying to design into reporting, but also guiding some of the decision makings at a large scale. And obviously, it was funded by the Reef Trust Partnership and AIMS as well. The rationale of why we started this work is because we do a lot of monitoring across the reef that covers various different dimensions of the ecology of the systems, but also there's a lot of research that adds value to that. Like in EcoRab, there's a lot of assessments of the demographics and understanding of the relationships to habitat and environmental conditions. But it's also a lot of published research done along the way to actually help us understanding how the reef functions and how the reef transitions over time. But on the other side of it, we want to actually simplify that in a way that we can make decisions a lot quicker and more informed. But having all these different dimensions is always very challenging to convey and to prioritize what are the areas that needs attention and why. So we kind of came up with this black box that we're trying to kind of push everything together into some way to actually summarize and convey the message about what the condition of the reef is. So Reef 2050 has a target that says that we need to maintain a good condition of the reef, but what is a good condition? How do we define that in a quantitative way? That's the reason why we started doing this work. So there's been previous work done in defining some of the key indicators that we think that are relevant, and that a lot of those metrics has been monitored for over 30 years in the Great Barrier Reef. But we actually start teaching apart a little bit more what do they indicate and what do they tell us about. So we have coral cover as a bit more sort of generic proxy for ecological services, for maintaining key processes. We also have macroalgae cover as a sort of as an indicator of competitive pressures and space availability for recovery. Community composition, more and more obvious, we're kind of realizing that reef are actually changing, and we need to kind of acknowledge the fact that the composition indicates a little bit the stability of the system if it's changing. Recovery performance as a way of a metric to indicate whether the reef is going in the right direction or not, and juvenile density as a way of measuring the capability of the reef to actually kickstart that recovery. But the other part of this work was trying to understand how we set expectations to those indicators. Because the reef is so vast and so diverse, how do we acknowledge that the reef is so different, but at the same time setting some values that can help us guide in policy making and decision making, and to say, hey, your reef is in good condition or not good condition. So we have here in this diagram or this graph, the different indicators, and sort of if you imagine one of those, then you can see that sort of they varies over time quite a lot. And sort of to start setting up those expectations, we first looked at, can we set up some reference that indicates the maintenance of those functions that those indicators indicate, but also give us a reference to say, well, are we actually above or below that value? And I'll explain that in a little bit. But we also realized that below the maintenance threshold, that's the part where we really want to tackle that sort of the decision-making part. And if we actually leave it too late, then we might actually be in a bit of a pickle situation where sort of it's a little bit too late for us to make decisions. So we wanted to actually find a contextual threshold that I explain what it means, but actually give us a bit more of a reference to know when the reef are actually in a much more critical situation. And some of that is actually trying to recognize that reef bounce back and forward. So we want to actually understand not only that the reef is in a relatively bad shape at some point, but whether they have the capacity to recover or not in the following years. So if I give you an example with coral cover, you can easily see sort of values of coral cover going up and down, and sort of what I'm going to talk about is those thresholds that indicates the maintenance or the contextual values of those indicators over time. And if you can think about it, then you can actually put a scale to that. So if you're above the maintenance thresholds, you're in a much better situation. But the critical or contextual threshold is what actually gives us that indications of a very poor state or critical values. But acknowledging that sort of the reef, as I say, is very variable, we needed to actually set up some spatial references to know that that we are talking about the same thing. So we used the bioregions as environmental provinces to actually outline or separate those reefs that we think that are more homogeneous compared to the rest of the other reef in the Great Barrier Reef. So this is the work that's been done back in the days in 2001 that delineates the bioregions based on the environmental provinces of the GBR. So having a spatial reference gives us a little bit of a bit more of a summary, but we also needed to acknowledge that the reef varies over time and a lot. So we needed to actually set a reference to understand what is our we call it baselines to define those thresholds. And I just put it in inverted commas because our monitoring has only been happening for 30 years, so our baselines is relatively recent. But in that period, we have realized in this work by Mike Amesley that the amount of disturbance that a reef has suffered, or the number of reefs that have been suffering disturbance over the years have increased dramatically in the last 2 decades. And if you see those, the graph on the left, that's the proportion of reef over time that have been affected by several disturbances. But on the right is also the timing in between disturbances has also been shortened. So it means that the reef have much less capacity to recover. So we identify the time from the beginning of our monitoring in the 1990s to about the 2010, where things got a lot much worse. And that's the time that we use as our reference for the thresholds. Then when we talk about the contextual threshold, so those values that indicate as critical states, that's the coolest part of this project, I think, because that's when we started looking a little bit more about the theory of what we understand about the systems. So it's no longer driven by our data, but more so driven by the ecology and trying to use that to add some additional values to those observations that we see in the reef. So, for instance, when you look at coral cover, we investigated what's the values of coral covers at which carbon budget becomes more negative. This is work done by Pinmummy and was done across various different bioregions as well to then generalize on what's the values at which coral cover are actually too low to limit the carbon budgets in the region. There's also some work being done in terms of relationship between juveniles and macroalgae that helps us understand at what point the amount of macroalgae can actually limit the juveniles and that therefore causing bottlenecks in the systems. With the community composition, we looked at novel states of the communities and trying to using this analysis that's called local outlier factor as a neighborhood analysis to identify at what point the the novel states of the community becomes more settled in the systems, and therefore more likely to actually change over time, or remain there over time, and therefore changing the way how the reef looks like and operates into the future. In terms of the recovery rates, we use a recovery model that uses coral cover over time, and then predicting what's the likelihood of a reef to actually stay underperforming or not in a particular year in terms of the recovery trajectories. And then for the juveniles, we use a lot of data from EcoRab, but also work done by Chris Doropoulos and others to try to feed in some of those demographic rates that Chris was talking about into integral population models to predict at what point what's the minimum number of juveniles that you need to have in a reef to prevent recovery of the reef. So at what point the juveniles becomes too low that then the reef doesn't recover anymore. So we were sort of looking at that work with JCU as well. So very quickly on this, then the last part is about the interpretation of it. So when we put it together, then we can quickly identify sort of the best and the worst scenarios. But the most interesting part is those warning cases where sort of there's not necessarily entirely everything is pear-shaped, but there are some combination of parameters that are doing well and bad. And sort of without necessarily getting into this horrendogram too much, but I just wanted to show you that then we needed to actually get somewhere that we can summarize this even further to actually identify what are the reefs that are the highest risk of perhaps continuing a degrading trajectory. So we looked at a more sequential process in terms of like state variables like coral cover at the top, recovery trends in the middle, and then processes like recovery, recovery and juveniles and macroalgae to try to then tease apart at what points they're actually in a much more risky scenarios. So if you look to that, for instance, to the left of that, you follow that, you have like high coral cover, your reef is recovering really well, and then your processes are actually working quite well, so you are in a relatively low risk and good condition. But if you go to the right, you are in the worst situations. When you are in the middle is when you start teasing apart a little bit more why the reef is actually not necessarily in a relatively good conditions and what are the risks that the reef is actually less likely to recover. Because I'm a bit of a geek, I also sort of then trying to put that together into more of a dashboard where then you can use auto-generated text to provide context to those that are making interpretations out of that. So this is a draft of work that we're trying to formalize a little bit more, but it's a shiny app that helps us to then navigate through the reef, allowing to looked at different scenarios, test our assumptions of these indicators, but also being able to add a lot more context, like how many what are the species that are increasing or decreasing in the reef, like what's the context around the density of juveniles and so on, to help communicating the complexity of the reef in a more kind of structured way, if I put it that way. So I'll leave you with that. If you're interested, there's a QR code, you can have a look at that. But if you're interested in reading a little bit more about it, we also have all that documented, so there's a QR code there for that. Thanks a lot for
Thanks, Manu. Chris.
Great talk, Manu. It's awesome work. Super exciting. I'm just a detailed question, I guess. You're talking about novel community states. What kind of level of community are you working at? Functional, species composition? Can you just elaborate a little bit on that?
Sure. That's a good question. We've been using the lowest taxonomic level that we can get from photograph from the long-term monitoring program. Most of that is at the genus level and is updated to the newest taxonomy now. But in some cases, we can get to morphotaxa. That's kind of where we are. And unfortunately, the soft corals are a little bit underrepresented in terms of taxonomic resolution. Sorry, Katerina.
This is not a question, just a clarification, just in case. The auto-generated text doesn't use artificial intelligence to generate the text. It's actually based on rules that we write, because everything now to generate at the moment is ChatGPT.
Yeah.
That's not what that is, just clarifying that.
Yeah, good point, thank you. We might get there.
One more quick question? No? Okay, thank you.
Thank you.
Thanks so much. Next, I'd like to introduce Peter Butcherine.
Thanks very much, everyone, for staying for my talk. I'd like to start by acknowledging the traditional owners of the lands on where we meet and the land and sea country where we do our research. First of all, my name's Peter. I'm a multidisciplinary research scientist from Southern Cross University. I'm relatively new into working with reefs. I come from a background of working in aquaculture and also ecotoxicology, so this is something that's going to be completely different. My talk today is the potential applications of remote sensing for mapping plumes in reef systems. I work as one of the team member of the RAP cooling and shading team. My presentation today will just give a brief overview of what we do, what we use now to measure our plumes, introduce 2 new instruments that we've added, and give a bit of, sort of like preliminary data for our recent field work that we've just finished, and give some future directions and some potential, I guess, opportunities for, collaboration, data sharing amongst the different teams. The cooling and shading sub-program has been developing 2 technologies. We've got the seawater fogging technology and the Marine Cloud Brightening technology. They are designed for different spatial as well as temporal scales. The fog that we generate sits relatively low over the water. It's designed to shade the reefs directly, whereas the Marine Cloud Brightening, the MCB, is really designed to generate salt, which then will actually convect up into the marine cloud. It then actually perturbates the cloud and improves the reflectivity by increasing albedo. Okay, Southern Cross University has actually fitted out a Cessna 337 Skymaster, affectionately known as Bruce. It's been fitted with a range of scientific instruments that's really sort of operate in that, cloud microphysics space, so something entirely different to what you're looking at on reefs. These instruments are designed to measure aerosol distributions and sizes. We also gather radiometric data. We look at things like cloud microphysics properties. We also collect general meteorological data like relative humidity, temperature, wind, speed, direction, etc., and also aircraft, and also using GPS through aircraft positioning. The instruments will actually collect samples of droplets and individual particles from about 10 nanometers up to about 2,500 nanometers. The main aim of this aircraft at the moment is that we want to actually characterise the MCB and fogging plumes, so looking at size and distribution of particles, the potential for light reflectivity. We're also monitoring those sort of interactions between the actual generated aerosol with the marine cloud to see whether we are actually perturbating these clouds, and also indeed to actually test whether they're actually susceptible to these little bits of salt crystals. Unfortunately, the one thing that's really missing from this whole kit is we don't really know the size of the plumes we generate and their 3D extent, and also indeed the actual changes of light field through the plumes. Hence, we've now added in a couple of remote sensing instruments. So we've added in, this one here is our HiSpecs V620 hyperspectral camera. It's actually a push broom style camera, if you understand. It actually collects data on 700 wave bands from about 400 nanometers through to about 2500 nanometers. The visual range, sort of 400 to 700 thereabouts, is aimed, I guess, primarily at this stage, looking at reefs, whereas the shortwave infrared, which is sort of from the 800 to 2500, is more useful when we look at the clouds and plumes and things. The bathymetric LiDAR, mainly designed to look at shallow water and coastal type environments, historically and most broadly used to generate three-dimensional models. We're going to be using this to look at the surface of the plume, so we can actually map, and also in terms of the surfaces, also look at the surface of clouds. So we can actually assign individual heights to the individual pixels of the hyperspectral camera, because there's a lot of cloud microphysical properties that rely on an exact knowledge of altitude. So that'll help us drive that knowledge. The addition of these instruments has improved or will improve our capabilities. You're all aware that there's a lot of technology with drones. They've certainly improved the access to information, but they're relatively limited in their range, and they are impacted by weather fairly significantly when you then compare it also to satellite. The resolution of most satellite products at the moment over the ocean are about 1 kilometre square. We're operating in a range of, resolution down to about 20 centimetres square. So as I said, LiDARs are generally designing three-dimensional structures of reefs and land masses. Here we've got a little DEM we've created of a charity reef at about a 0.5 metre by 0.5 metre square. We can get returns from the LiDAR down to about 15, 20 metres, really dependent on water clarity. Using the LiDAR, we can actually make estimations on the albedo of individual plumes using full waveform analysis, something similar to what we use in a celiometer. We can estimate the amount of shading we can generate through the plume at various sections through the plume. We also examine individual edge effects for light fields modifications. And of course, we can measure plume's extent, most useful for the seawater fogging. Now, in the interest of time, I'll only run through looking at the plume. In our recent field campaign, we were on the Whitsundays. The weather wasn't the best. We didn't manage to actually LiDAR the actual fogging plume, but we did for the MCB plume. So what I'm going to show you is some more, I guess, proof of concept data, just to show what we can do. So here is what we found with the MCB plume. This is a single flight, 500 feet, 100 knots, so for the uninitiated, about 150 metres at about 180 feet, about 185 kilometres an hour. Single pass right over the top of the boat, we're able to get this. And as you can see, we've got about a 300 metre plume, and we've got a vertical development of about 20 metres. Now, this is not its primary use case, but this is fairly encouraging. Similarly, when we look at the top-down view, we can see there's actual, some form of horizontal development. We've got about a 30-metre development here. So while this is only preliminary and it's not its actual primary use, it shows that we are able to use this sort of information to measure volume and the lateral and vertical development of these plumes. We do expect to get much better resolution from the fogging plumes, and that's mainly a function of the size of the droplets. As you can see, the fogging plumes are much larger in droplet size. This is actually where the LiDAR laser sits in terms of its wavelength, so we're expecting to get a lot better returns, simply based on the overlap of that size distribution of the individual particles. For comparison, the figure there on the side is of one of our fogging plumes. It's about 600 metres long and about 100 metres wide. So it's significantly bigger than your Marine Cloud Brightening plumes. When we look at the hyperspectral data, this is a small section of Heron Reef that we captured about 2 weeks ago. It's sort of traditionally been used to focus on terrestrial and shallow water environments for, you know, change analysis and materials classification, etc. However, these analyses rely on sort of extracting individual spectra from regions of interest and then generating interesting products that show what you want. But the high dimensionality of this hyperspectral data will allow the detection of regions of image that are maskable or of interest so that we can actually focus on those. When we apply this to our plumes, you can see there's the opportunity that we can actually find a lot more information, and we can potentially also see any interactions with what's going on with the light fields on the reefs that are actually underneath the plumes. So what are we looking for in the future? Well, we're already actively working on trying to use the LiDAR data to build up some fine-scale modelling, and we can also look at the reef analysis to support habitats for restoration. We can use the combined data to work on trying to identify those suitable habitats, whether it's less rubble, more rubble, whatever's available. And we're also designing a machine learning algorithm to help us actually do the early detection of bleaching. So in summary, we are able to use these instruments to find plumes, but that's just the tip of the iceberg of the information that we can actually get out of these. Listening to a lot of the talks here over the last day and a half, I see a lot of pain points that potentially could use this sort of data. So if it's of any use, just get in touch. We're more than happy to help. So thanks very much.
Any questions? How long do you find those fog plumes last?
The fog plumes are very dependent on wind, as you'd expect. You probably, from when the machines are turned off, 15, 20 minutes, it's very much like having a low-level cloud for the fog. For the MCB stuff, it's really not about the plume. It's all about the salt.
Thanks, Peter. With the detection of very small particles, can plumes and small particles in the water be tracked, or is it only those tiny particles in the air?
Not something we've looked at, but owing to the fact that the resolution is sort of a square this size, if it's got some light property that we could look at in the spectra, then potentially, because obviously they can track algae from space. So if it's something that we can get a spectral return from, then potentially there is opportunity.
Sherry?
I'm just going to add to that question, which is the answer is yes, you can detect plastics using this kind of technology, so which is what I'm interested in. But my actual question was, what is the salt? Is it just sodium chloride? Is it a mixture of salts?
It's just seawater.
It's just seawater.
Just seawater. All we do is, and there'll be more about this in some of the presentations tomorrow. But literally, they just need to pump the seawater out. It gets filtered, and then it gets sprayed out at under high pressure.
So I'm particularly interested in that because there's a chemical known as DMSP, which is produced by corals and then gets converted to DMS, and it's a salt that can be readily dissolved in seawater and then sprayed, and it's linked with cloud or sulfur cycling, and I think that could be a particularly interesting area to consider.
It's something we're already looking at in terms of the atmospheric stuff, yes.
Perfect.
All right, we'll just take one more question from our online audience. For implementation of FOG, the dispersion would primarily rely upon prevailing wind conditions. How do you expect the coverage to change for stationary sources?
Yes, the wind does have a significant impact on its dispersion. The envisaged scenario, I guess if that's the right word, is that you'd actually have multiple stations around a high-value reef, and it is really dependent on the wind, so we need to have those low, almost sort of like doldrum-like conditions for it to be effective, which thankfully do occur over the reef during summer. And the idea is by having multiple points is that we can try and alleviate the effect of that wind drift, you know, at least minimise it anyway. Yeah.
Okay, can you join me in thanking Peter, please? Next, we've got Renata Ferrari Legorreta.
Thank you. Hi, my name is Renata Ferrari. I work at the Australian Institute of Marine Science, and I'm part of the ECORAP team, or Ecological Intelligence for Reef Restoration and Adaptation program. I also, from very young, have had a problem with the default, like being told, this is how we do things. I've always wondered, is there a better way of doing it? Can we learn more from this if we look at it from a different perspective? And I think that attribute has stuck with me because I'm usually looking for better ways of questioning the reef and understanding what happens to it. Because before I continue, I'd like to acknowledge the traditional owners and custodians of the country where we meet for the Reef Resilience Symposium and workshops here in Cairns. I pay my respects to their elders, past, present, and future, and the future leaders of tomorrow. I would also like to extend these acknowledgements to all Aboriginal and Torres Strait Island traditional owners and custodians of the land, seas, and waters where ECORAP and AIMS researchers and collaborators live, work, and conduct our research with full, free, prior consent. So I'm not going to dwell too much on what is ECORAP because there's been some really, really good talks, Katerina's yesterday and Chris's at the beginning of this session today. But in a nutshell, ECORAP aims to quantify natural rates of recovery and adaptation in response to global and local changes, as well as rates of recovery in response to interventions. In other words, our objective is to optimize interventions by understanding the how, where, and when of natural reef recovery. So while we're not doing active restoration interventions, our team aims to inform how to best succeed at those interventions through understanding the ecological context behind the interventions and in the reefs and the locations where the interventions happen. So hopefully this works. Recovery, this is a video I'll start in a minute, but recovery trajectories are not only influenced by the individual demographic rates that happen in the reefs, the identity and relative contribution of organisms in the benthic community also drives differences in recovery trajectories. This can be associated to the innate properties of each species or their traits and or their immediate emerging properties. As reefs recover, it's really important to understand not only the distance between coral colonies, but also how this varies in 3 dimensions. Reefs are 3D, not 2D. And the key demographic gaps in knowledge for coral colonies are huge. I mean, we think we understand the growth of Poraites bommies really well because we have about 300 corals cored over time, and the cores are about this size for colonies that are really big. We know a lot already, but there's a lot more that we need to understand. Using 3-dimensional models, we can tackle some of these questions. And I think this conference's most popular image is one that was done by George Roth from CSIRO, which shows a large area of reef before and after the bleaching event around Lizard Island, I believe. There's lots of amazing images that are coming out from reefs, some from underwater, some from drones, some from satellites. Technology is there, but there's still a gap in terms of how do we extract knowledge and turn that into advice to understand how to do things better and how to boost the success of reef restoration. Well, that's where I thrive. I like figuring hard problems out. So a big part of my job is to figure that out. How do you actually turn that image into information and intelligence? So this is the EcoRAP study design. As you can see, we have about 12 to 19 reefs, depending how you count them, all the way from the south in the Capricorn Bunkers to the north in the Torres Strait. We have reefs inshore and offshore. And we were really, really interested in complementing the long-term monitoring data with knowledge and data of what happens within reef, how these dynamics and the different key indicators, like the ones that Manu talked about today, change in different sites around the reef and with the depth gradient. And that's what our design tackled. We have reefs we have sites on a given reef that are spread around the perimeter of the reef. They cover 4 key habitats, and that's they vary with wind exposure. So we have front reef, flank reefs, which intermediate wind exposure, and back reefs. And we also have some sites on the lagoon. And we also have sites in shallow and deep reef slopes. And I say deep because we only go down to 15 meters. So it's still all within depths that restoration would happen. But we do know that there's quite a big difference in terms of the light and other processes that happen ecologically speaking between 3 meters and 15 meters. And that's the range that we look at. So at each of these sites, this is how a site looks. We have 4 high-resolution plots, and that's the data that I'm going to talk about today. Each of those plots are about 72 square meters or 12 by 6 meters, and we image them using high-resolution off-the-shelf cameras. On top of that, we have GoPro plots, which are about 100 by 10 meters, and that's what you're looking at the screen right now. These are just imaged with off-the-shelf GoPro cameras, and we can get 3-dimensional and 2-dimensional maps, like the one you're looking at right now, that are about 1 centimeter in resolution for the GoPros. The DSLR plots give us resolutions of sub-millimeter, about 0.03 millimeters, I believe. And this is how one of those high-resolution plots look. So again, beautiful photo. This one's actually lower resolution because it would have been too slow for the screen to display. But what we do is we use machine learning and a lot of person time initially to train the machine learning algorithms to outline the corals of interest. As you can see, not all the corals are outlined there, only the most common ones, because the training does take a huge amount of effort and person time. So we have one fully dedicated staff that she's a benthic ecologist, and she has put a lot of time in training this machine learning, but now we can automatically detect 11 of the most common coral taxa, which actually represent about 55% of the coral cover in our entire data set. And once we have those maps digitized, the same benthic ecologist goes down and verifies a subset of those corals, makes sure that those are the species that she's attributed from the images, because as many here might know, not all coral species can be reliably identified from images. Because of that, we have a mix of coral species for those that we're confident about, and genus or morphotaxa, which are, for example, tabulate Acropora, because we're not confident that we can identify the species from the images that we have. So what have we learned after 3.5 years using this amazing data set? I'm going to talk about a few highlights. The first one is the distribution of the most dominant corals across the Great Barrier Reef and the Torres Strait. So who are the most common dominant corals across our entire region? There was no big surprises there. There's some massives, like massive Porides, Goniastrias, and Platygyras. There's also what I've termed tables and thin branching corals, mostly Acroporas. Most of them are Acropora corymboses and Acropora tables. And then we have what I've termed thick branches, which are mostly in the Posilopora family. But in a minute, you'll see that the Acropora digitate corals are very similar in size to the Posiloporas, and they also behave quite similarly in some in some regards. So this is really important when you're trying to parameterize ecosystem models and understand what's going to happen with different impacts and what to expect from these groups. So where are they? I hope you don't get intimidated by this plot. This is simply showing what the latitudinal gradient of those different dominant corals is. This is data from 2021 to 2022. All of this data comes from about the same 6 months across all of our sites. And you can see there's variation, but the most interesting part, if I can point, is the inshore reefs. So this will be our southern inshore reefs or Pebble Island. And this one here is our inshore central or Palm Islands cluster. And you can see that they have a lot less corals in big summary. And also you can see for Porites massives, there's an important decrease from north to south. So there's more Porites massives, a lot more dominance of Porites massives in the north, in the Torres Strait, and in the central compared to our south or southern reefs. And this is a similar graph for wave exposure, or the wave exposure gradient I was talking about before. So again, you can see how the most exposed reefs or front reef slopes, both deep and shallow, have more corals than the least exposed reefs or lagoonal reefs. But there's a fairly obvious gradient. You have to remember this data set is comprised of more than 20,000 corals. So it's huge variation. And just being able to pick up these patterns at this level or this scale is pretty incredible. We also looked at about 12 different environmental and biophysical predictors of what determines the abundance and the prevalence of these 20,000 corals. And I'm only going to tell you a little bit about the most important ones. So the most important ones was the depth gradient between 3 and 15 meters depth, water clarity, and temperature. This plot has triangles for abundance and circles for prevalence, and blue is good, so that means that there's more of. And red is bad, that means it's less off. And you can see that dashed line is 0. So anything to the left of that dashed line would be red, and anything to the right would be blue. And then anything that's kind of faded out, like for Platygyra in the middle there, is overlapping 0, so it's not significant, or there was not an effect. So for example, in this case, we were comparing deep and shallow. Deep is anything below 10 meters or 9 meters depth, and shallow is above. And we can see that Platygyra is equally abundant and prevalent across the depth range we studied, but all other corals, there's more prevalence and more abundance of corals in the shallow areas of our reef slopes and lagoons. And then temperature and water clarity were also important, and I was really interested to see that for juveniles, thank you, that was also important. Water clarity was generally good for corals. 6 of our 9 taxa were more abundant and prevalent where there were clearer waters, and temperature had contrasting effects. Some corals preferred warmer waters, and some corals prefer cooler waters. The second bit of results I'd like to brush over really quickly is growth and survival. So we looked at the growth and survival between 21 and 22 for our corals, only for a subset of them, so about 10,000 of the 20,000. And we found pretty much that for coral survival, there's a huge difference. You have to remember, this is a year without disturbance. And there's a huge difference between our 3 different groups of corals. So fine branching Sacropora tables and corymboses are the most likely to die. Here, along the y-axis, the closer you are to 1, the more likely you are to die. And then the massives are the least likely to die. Initial area was everything. Size matters. The bigger you are, the less likely you are to die. And temperature was also important, but interestingly, it wasn't like the cooler waters or the hotter waters were better or worse. Temperature within our range explained about 12% of the variation in mortality. And the ideal the ideal temperature range was between 25.5 and 28.5 degrees. So that's the ideal for the corals that we're studying in our spatial range. And finally, for growth, size was also extremely important. It explained, depending on the taxa, it explained between 40 and 70% of growth of adult corals. These are corals between 5 centimeters and about 1.2 meters. There's some that are bigger, and this is in diameter. We actually measure the size of corals in centimeters squared, so the area. But I have, just for people that are used to thinking in centimeters diameter, I have written the equivalences up there. For the thick branching corals, so Poecilopora, Stylophora, and Acropora digitate, we can see that they only get to about 50 centimeters in diameter, but still, the bigger they are, the faster they grow. For Goniastras and Platygyras, we have the same trend. For Borealis massives, it's gradual and it just keeps increasing. And this does not agree with what we know about Borealis massives. Borealis massives from core measurements don't seem to grow faster as they grow bigger, but when you actually measure their planar area, they do. So there might be some really interesting lessons there. And finally, the ones that I found the most interesting are the Acropora corymbuses and Acropora tables, especially because there's an inflection. When they're really small, they grow really fast, and then they keep growing faster as they get bigger, but they kind of stabilize a little bit more. So there's a point where they will kind of put more energy into other processes, like reproduction potentially. And the size, so size is important, size matters. Are there any patterns or changes across our entire study design in terms of the size frequency distribution of these corals? In short, because I'm short with time, but you can come and talk to me later, there aren't many. There's a little bit of a trend. Inshore reefs seem to have larger corals compared to offshore reefs, but we couldn't find any evidence the size frequency distribution of our most dominant corals, and that you can see that because there's overlap in between these histograms across all of our clusters and across our inshore and offshore reefs don't really separate. So corals seem to not have a huge difference in size frequency distributions between our different habitats, our different depths, our different inshore, offshore, and our different latitudinal gradient. So how does this translate into restoration? Well, when you're choosing the right environment for your right taxa, you definitely need to think about survival and growth, and you need to know what the right place is for your corals. So we can use this information to answer questions like, do flanks have more corals than other habitats? What are the dominant taxa in different habitats, different depths, water clarity, etc.? So we produce species distribution models for each of these taxa. And if I zoom in into just one of them, I can do a little recommendations or tips card. So there, yellow means there's more higher density or more abundance of these corals, and purple or dark blue means there's less. So you can see that for massive poraites, they prefer the edge of the reef. So they prefer narrow ranges in temperature. North is better than south for massive poraites. They also peak up to girth at around 2,000 centimeters squares, or 50 centimeters in diameter, and then they steady increase in growth rate with size up to 10,000 centimeters square, or 112 centimeters in diameter. It is important to note that our plots are only 72 square meters, and I don't think we're capturing the really, really, really big, massive poraites. That's work to be done with our GoPro plots, but we don't have that data yet. Probably the biggest coral that we capture in these results is up to about 2 meters in diameter. And they prefer low exposure and shallow habitats. On the other side of the spectrum, we have Corymbus acroporas, and I'm gonna just quickly click through that because I'm out of time. And then in terms of survival highlights, we also have these key bits of information. So which taxa are better at surviving? What's the size that they survive best at? What's the percent cover that they will do better at? That one's a really important one. There's like an optimal percent cover. And then what's the ideal temperature they'll survive at? And for growth, we have similar information coming down. And with that, I'm going to say thank you, and sorry for going over time.
Super quick question. Okay. Renata's very passionate about her work, so you should catch up with her in the lunch break. Can we invite Tanya now? Tanya Dodgen, thank you.
Thanks. Hi, my name is Tanya, and in the spirit of the conference, I just wanted to open with a little bit about myself. So I did a Bachelor of Science in Biology and then took a few years off, but sort of kept my foot in the marine science world by volunteering for Reef Check before coming back to QUT to do a PhD with RRAP in the Rebel Stabilization Subprogram. And a fun fact about me is that I am a different person from one of my supervisors. She will be speaking after me. Her name is Tanya. She did a bachelor's degree in ecology. She took some years off before coming back to do a PhD in Rebel at UQ and did a lot of volunteering with Reef Check before that and is now a postdoc in the Rebel Stabilization Subprogram. I think the main difference between us is that she has a puppy and I don't. And she has a few more years experience, so save the hard questions for her. So without further ado, I'd like to get started by acknowledging the traditional owners where I work and study, and also further acknowledge that these places have always been spaces of teaching and learning. Today I want to talk to you about coral rubble and a little pitch for why we should care more about rubble, and some opportunities we have to understand rubble at scale that are very recent in the past couple of years, but I want to highlight the limitations around those data sets that at this point in time are not really fit for purpose for this particular substrate, and how I'm working to sort of improve some of that. So what is coral rubble? We have this concept of a healthy coral reef, and when there is degradation, we can see areas of healthy reef degrading to rubble-dominated areas. And in the GBR, where my research is focused, we're really worried about increasing cyclones in the future and these mass death like bleaching and COTS-induced disturbances. And we're interested in understanding that type of substrate because, as you've seen everywhere in this conference, we want to prioritize restoration and understand where restoration is necessary and potentially effective to pull rubble environments back to these thriving coral reef environments. However, restoration is expensive, restoration has risks, and I don't have a lot of time to talk about this today, but rubble is really cool. It's just this absolutely biodiverse environment. It has a lot of recruits in some cases for coral, echinoderms, mollusks, ascidians, bryozoans, all these things that are not the coral, and we haven't had a lot of time to investigate, but we don't want to necessarily intervene with that habitat unless we know that we need to, and that there's going to be a value in that intervention. So when should we think about restoring rubble? I would argue that we need to think about rubble in a temporal sense, and rubble is worth intervening in when that rubble cover is increasing, but coral cover is decreasing. So rubble is everywhere on reefs. I'm sure most of you have seen it. It's that natural cycle of life and death on the reef. The coral grows, it dies, and it creates this habitat for all these cryptic organisms. So we don't want to just look at rubble and necessarily immediately think of it as bad. But then we have large disturbances that create rubble quickly. So in this very simplified graph I've showed you here, I think of that transient area of rubble where the reef still has this resilience capacity. So in this image from St. Crispin Reef, there's these areas of rubble that we think were the result of a cyclone, but there's just a lot of evidence of corals quickly springing up in that space. So it might not be worth investing in restoration there. And then we have some other areas. This photo's from Moore Reef that we think hasn't really recovered since Cyclone Yasi, and that's that orange line there where we have evidence and observations that this area used to have high coral cover, but is now this sort of degraded environment. So that might be the type of area we want to target. But in order to understand and know about that, we need information about rubble over large areas and over large spans of time. Otherwise, we can't make this sort of, we can't see this from a single point in time photo. So lucky for us, and thank you probably to many of you in the room right now, we have increasing observations of coral reefs over time. But for either intentionally or unintentionally, rubble has often been this forgotten substrate. And it's either not targeted because it's not coral, or it's kind of looked over because it's not as beautiful or valuable potentially aesthetically. So keeping that in mind, I want to talk about products that we now have that are really cool, and then go into the limitations that are created by this sort of blindness to rubble as a substrate category. So in 2021, GRIMPA published, the Reef Authority published some maps at the scale of the GBR for offshore reefs. It's ongoing work. I'm told they're going to produce some newer, better maps covering inshore reefs as well sometime soon. And we have, at this scale, based on satellite imagery, this really cool, simple but important information about benthic cover across the reef. And lucky for me, one of those categories in that is rubble. So that creates some pretty cool opportunities to look at rubble at the scale of the GBR, which wouldn't really previously have been possible. But for now, this is just a snapshot based on 2018 data. And also, what I've found digging into this is that we really need to be careful about a successful sort of model output, and especially a model that's really doing a lot at a big scale and generating a lot of information, and using it in this sort of like niche market of rubble research, which is still quite a small area relative to a lot of other areas. So I'm gonna summarize about probably over a decade worth of effort and modeling into 3 pie charts. I'm not a modeler, so if you want to know more about models, talk to someone else, but I hope that this is conceptually a sort of simple step through of why we really need to be careful in the way we use these products. So conceptually, go on this journey with me. We started out and we wanted to teach a computer to say if something was coral or not coral. Success in that space, in that situation for a model is above 50%. So 50% is random. There's 2 categories. If we can get it to do better than that, then in a way we've succeeded. And obviously this is iterative and we're always improving. But this is opposed to sort of human accuracy, where we would kind of expect an expert to be able to tell you always if it's a coral or not a coral. That becomes different with different qualities and scales of imagery, but go with me on this conceptual journey. Then we add more categories. And so, again, accuracy is very complicated. The ways you calculate it are variable. But at the end of the day, if we get sort of 25% success in a model with these 4 categories, then we're better than random. And again, human success is going to be variable, but we would want an expert human to be quite accurate if we're looking at these 4 categories. But what happens in most of these benthic mapping efforts over the last sort of 10 to 20 years is that rubble, if it is a category in the map, is quite small. And so much like a human would, the model goes, well, hey, so this is that actual data on the GBR. Rubble is about 7% cover across the reef. That's relatively consistent across regions and across individual reefs. That model could theoretically be 93% accurate and get rubble wrong 100% of the time. And in fact, this is sort of what I've found in a sort of a literature review space. So I'm going to highlight 3 studies, and it might look like I'm picking on those 3 studies, but what I actually want to highlight is that these are kind of the best of the best in terms of what I've found. They are often doing geomorphic categories and benthic categories. They're looking at a lot of levels, and some of those categories they're doing really, really well. And these are the studies that have actually published what their categories are and what the accuracy for those categories is. So many studies say, hey, we did 50 categories, but our main goal was coral, and so here's the published results for 7 of those categories that actually worked. So for me, it's incredibly valuable when studies produce in a big appendix, perhaps, not in the paper itself, but actually publish the categories and what the accuracy is for all of those categories. So these studies are to be commended, not, even though it might look like I'm about to pick on them. So the first thing to keep in mind, going back to our lovely pie charts, is that 4 is actually a very small number of categories, and a lot of these studies are trying to do way more. So keeping that in mind, if they have a whole bunch of categories and rubble, in my case, is just a small one, you can imagine what that leads to. In some cases, it leads to accuracies of between 0 and 2%. Why do we get this? So that top one was one of these things that I'm talking about has a really big effort, so it put a lot of work into its geomorphic categories, and they have really beautiful papers and data and publishing at that level. And they have some of that available for benthic classes as well, but it's kind of like the first stepping stone in that space. It's not fit for purpose yet, I would say. For rubble specifically, it does better in other categories. Then this middle paper, going back a little bit, did some mapping of the GBR, and they kind of split it up into regions, so they have different ground truthing strategies. And in some of these regions where you don't get rubble because they're not photographing every square inch of the reef, you get a lack of validation. So they have a 0% accuracy, but what that actually means is that they just didn't have enough data to verify rubble cover at all. So it's not, it's essentially a placeholder figure saying that this just isn't available, even though it was something that was initially sort of built into the design of the study. Then in which cases do we kind of get a little bit better? That same study for other regions of the GBR had really variable accuracy. And so again, this is just highlighting that in areas where they had a bit more observations of rubble, they were able to pretty rapidly improve that accuracy around this category. And then for this final study on the bottom there, they have sort of 34% accuracy. And a big confounding factor in that study was looking at rubble as rock. So rubble is a challenge because it's highly variable visually, and this key quality ecologically of rubble is that when it's loose and when it actually realizes its potential as a loose substrate and becomes mobile, it has all these impacts of killing coral recruits and needing that restoration intervention. But we can't actually tell that yet from most mapping efforts. So this confounding between rock and rubble is very understandable and very difficult to resolve for large-scale mapping efforts, but pretty crucial when we're trying to use these for management applications. So we need to keep in mind that that's not something yet that we can do reliably. So I would say this is a little bit of the unglamorous part of research, but I think it's really important. I've sort of stepped back from some of my initial ambitions in my PhD and trying to really clarify what rubble means and how it's defined when it's talked about in these mapping versus monitoring contexts, because it's sort of the same but different across these spaces. I'm trying to reanalyze some imagery from a rubble perspective and see if we can improve these accuracies. And I really want to encourage and advocate publication of these sort of confusion matrices, although I was a little bit sad when I first came across that term in the research. It felt too close to home. But yeah, so just advocate for publishing this sort of like the things that don't work in your study and letting that be a stepping stone for someone else's research into something that hasn't been targeted yet. So I think that rubble is really an interesting and important part of coral reef habitats, and it could be used as an indicator of degradation on larger scales. It's not quite yet fit for purpose, and so we need mapping efforts that focus on rubble to understand this aspect of the reef habitat better. And finally, there's just all of this amazing work, millions of images. I'm sure you're seeing it everywhere in the conference. We need to leverage those resources and work on ways to reanalyze that data that already exists, because it would be insane to not use that massive bank of imagery that we have from the last decade or so, or more in some cases. So with that, thank you very much. And any questions?
Any questions for Tanya? It's for the online paper.
Hello, great. Okay, we have a problem with, okay, you know what's a reef and you know what's rubble, kind of, but the sand-rubble interface, it's so much rubble is sandy rubble or rubbly sand, you know, so there is this integration that's a problem for us. And then, I guess, how do we categorize and how do we draw the line? And is there an ecological basis to what lives there that we can draw the line by looking at something? Like if it's got coral and algae versus it's yucky stuff, you know what I mean? So we're just confused on what is rubble and what is rubbly sand or sandy rubble.
I mentioned I'm part of the rubble stabilization subprogram, so I spent about a year thinking about what rubble was and what stabilization was. I think the short answer is that coming back to that problem of rubble hasn't been the focus. It's always been a sort of additional category. When we've had definition is a problem in so many areas. And when we have people that focus on, say, geomorphology, for example, there's a really good body of work where they've poured through I don't even know, a century of geological terminology to say, hey, we've refined it, this is how we've refined it, this is what it means. Not everybody has to use it, but at least here's a platform for how we define it and describe it. And that's it's a really big job, but I would love to see that done for Rubble as a platform for moving that research forward, because everyone has solved that problem in different ways. So some places have rubble, they have percentages. They might say like 10% rubble, 80% rubble. Ecologically, I think you'll hear a bit more about that in the next talk, but there's not a survey methodology. There's very little understood sort of holistically about the ecology of that environment. And so, no, that's a great idea, and it's a work in progress. But yeah, it fundamentally comes down to the few studies where it sort of has been a focus are often totally distant in space and time, and so we don't have consistency yet. But yeah, that's something we would, I think, as a team, we're kind of trying to work towards.
Please join me in thanking Tanya. Now I'd like to invite Tania Kenyon with the dog.
Hello. I'd like to start by acknowledging the traditional owners of the sea country on which we've done this work, the Wapabara, Naro, Gureng, Gurung, Bailey and Tarablang Bunda people. How do I do this? And yes, I am another Tanya. I work on Rubble also. I'm a Brizzy local, and I guess I fell in love with the ocean through visiting Stradbroke Island, Manduraba, for family holidays. So I'm going to talk to you today about different components of the Rubble Stabilisation sub-program and how they can be used to improve intervention, planning and deployment. So yeah, as Tanya's just said, reefs maybe have 6 to 9% rubble, but that number is potentially a big question mark. What we do know though is that corals are dying and dead corals make rubble. So yeah, bleaching events, cyclones all increasing in intensity and frequency. Other events such as COTS outbreaks and ship groundings as well, which are a lot more common on the GBR than you might think. They all generate coral rubble. And if this generated rubble hangs around long enough on reefs, that is like it's hanging around rather than being swept off somewhere, that's where it can create a problem. So yeah, loose rubble that's rolling around and killing coral recruits through that abrasion and burial. And so Suki in our lab and Pete did some estimations that around, depending what you call a rubble problem in terms of rubble cover, perhaps 20% of reefs likely develop a rubble problem on reefs, and that's due to their bathymetry. So they have these areas that can collect rubble. And then those rubble beds that are generated, as Tanya has said, they have different forms. So we've done some surveys at different locations, so inshore at Keppels and offshore at Heron, and in rubble beds in different exposures, different depths. We did a lot of measurements, so just a few of these, so rubble length, rubble bed thickness, and the binding. So rubble can get bound together by things like sponges, macroalgae, crustose coralline algae. They all work to glue, in some cases, glue the rubble together again into a stable substrate, which in theory is better for corals. So as Austin just pointed out, we can have rubble beds that might have very small pieces, unbranched pieces, quite thin rubble beds, and perhaps on sandy substrates. And these tend to be generally pretty unstable, so smaller unbranched pieces rolling around a lot. These rubble beds can be, like Tanya mentioned, persistent rubble beds. So the groove systems in like a spur and groove system, that would be a persistent rubble bed like this. So we don't really expect recovery in these areas because that's how they are geomorphologically. Other rubble beds that have better recovery prospects tend to have larger pieces, more branched pieces that are going to interlock better, which adds to the stability of that rubble bed. However, we also have to think about what is binding in that rubble bed and what's growing on the rubble. So In this case, so this is rubble beds in sheltered areas of Keppel, so we've got a lot of Lobophora growing over it, so that's acting to limit coral recovery in those areas. So the best recovery prospects for rubble beds tend to, again, have these larger branchy rubble that's interlocking, but the binders are more your sponges, Pacenalia, crustose coralline algae, etc. And we found that this was generally in areas, exposed areas, and shallower areas. So that was a bit counterintuitive because you'd expect shallow areas to have more rubble movement. So as long as the rubble can interlock or imbricate in those exposed shallow areas, you can expect better recovery prospects. So yeah, in terms of physical factors, the rubble length and the rubble bed thickness are some of the most important drivers in terms of predicting recovery potential in the rubble bed. So we found that both these factors correlated well with the probability of binding, so that is the rubble is getting bound together into a stable substrate, which could be better or worse for corals depending on what those binders are. So bringing this back to interventions, so interventions depend on the substrate condition, so the things like larval seeding, coral seeding, they're all depending on having that substrate, a good substrate for coral survival and growth, and interventions are needed on degraded areas, which are commonly going to include rubble. And this might be an obscure reference, but oils ain't oils, or rubble beds ain't rubble beds. So there are different kinds, and we need to be treating them differently when it comes to interventions, because that's going to affect our chance of intervention success. So we really need to be understanding the substrate condition, is the bottom line. And just a few examples after chats with Kathy Page and Carly Randall. So they're working on the coral seeding devices. And in this kind of environment, so this is the Keppel's rubble beds, so those larger branched pieces, the coral seeding devices actually just sort of fell into the matrix. They've got different designs now where they're more of an arm where they sit on top of the rubble bed. So that would be better for the falling through the matrix, but then you've got the Lobophora. So yeah, a few problems going on. And then I've also had a chat with Taylor Whitman. So this is another kind of rubble bed, so smaller rubble, perhaps on a sandy substrate. And this was in Moore Reef. And here she also had some problems with the coral seeding devices, so they were struggling. This was also despite the fact that it looks like quite a good site, so it's little patches of rubble and lots of coral around it. And it's also despite the fact that she stabilised these coral seeding devices, so the stability component has been taken out of it. And that brings me to my next point, which is that mobility of rubble, so the fact that rubble is unstable, in some cases, is not the whole story. And so Roima is a PhD student in MCEL as well, and she has shown this. So she's looked at coral recruitment on stabilised rubble, so that's bits of rubble tied onto a metal grid, and she's put that into a loose rubble habitat, an interlocked rubble habitat, and hard carbonate, or a pavement area. And what she's found that even when that rubble is stable, so we've got a number of coral settlers on the y-axis here, that settlement is still lower in the loose rubble habitat, even though the rubble pieces themselves that the corals are settling on are stable. And then as you increase the stability of that surrounding habitat, the number of settlers is increasing as well. What is going on here? There's a lot of work to be done, but I think some of the main things are the sediment, so higher sediment deposition in a loose rubble environment, which is linked to the flow, so different flow conditions in a loose rubble versus interlocked versus hard carbonate. You might have lower small-scale flow going on around smaller rubble pieces, and also just the proximity to that sediment as well. Competition as well, there could be different organisms growing on rubble of different sizes and morphologies, which has been shown actually. So this is all at quite a fine resolution. So what about scaling up this? So what about predicting rubble condition on a broader scale? So we might want to determine whether a rubble bed is likely to recover on its own, or whether some sort of intervention is needed. So if an intervention is needed, do we need to stabilise? So do we need to go in and stabilise before larval seeding or coral seeding? To do that, we would want to make sure that movement is actually the issue there. Or is the rubble already pretty stable, like those rubble beds in the Keppels, and maybe we actually need to do something different, like go in and do algal removal before or something like that. So to try and provide these answers, this is in a very small nutshell, as well as the rubble surveys that we did of different rubble bed types. We've also looked at binding rates, so that's putting out stabilised bits of rubble similar to what I showed with Romer's experiment, and tracking what's growing on it and what's binding and gluing that rubble together over time, and how strong those binds are. I'm not going to go into detail too much with this plot, but all I want you to take away is that as the rubble is stable for longer, so as time is increasing, more things are growing on that rubble and they're becoming stronger. So that line is going up. There is some variation, obviously, around the exposure and depth, but I'm not going to talk about that too much today. But we've also looked at, as well as the binding rates, the mobilisation of rubble, so what flow speeds moves pieces of rubble. And then we're going to, or we are currently, putting those things together basically to, oh, the little rubble's moving, to answer the question, in a given environment, so in a given environment, considering the hydrodynamic conditions, is the rubble going to be stable long enough to for binding to occur? Oh, sorry. And is it also going to withstand breakage from that movement? So this is, so as an example, if you have rubble stable for a shorter period of time, you might have binding by macroalgae. Macroalgae is not as strong as a crustose coralline algae. Obviously, it's not a calcifier, unless it's halimeda. So that might break. If the rubble's stable for a longer period of time, then you might have more sponge coralline algae coming in, and that potentially could withstand breakage. So Fikri in our lab is working on this at the moment. So he's putting the work together from the binding surveys, the binding rates, and wave conditions. So from Dave Callahan's everyday wave condition wave models. He's putting that together and basically answering this question for every cell on the GBR to come up with a probability of binding in each of those cells. I was going to go into this, but I don't have time, so I put it in the background. So then, once we have an idea of, okay, where is rubble more or less likely to bind, and hence we have an idea about the recovery potential, what do we do about it? So stabilisation methods there have been categorised into sort of three main types. So direct manipulation of the substrate, so that could be actually removing the rubble completely. Addition of stabilisation structures, so things like rock piles or reef stars, and use of biological techniques. So this includes things like the bioglues, which Brett will be talking about tomorrow. So we got together a whole bunch of managers and practitioners and researchers, a lot who are here at the conference over these couple of days, and we had a talk about what works and what doesn't in terms of stabilisation methods, because there's really not a lot of published literature out there on it. And what will basically become of this workshop is two products. So the rubble stabilisation guidelines, Suki again has been working on that in our lab. So that's in a draft form at the moment, and we envision that as being sort of the Bible of rubble stabilisation. That will be a very practical tool that practitioners anywhere, not just in Australia but globally as well, can pick up and decide what stabilisation method they use on their patch of reef. The second product is Bayesian Belief Net, which is a tool that will give guidance on what method to use based on your environment and other factors. Okay, so just some quick takeaways. So bigger rubble pieces, more branched rubble pieces, and thicker rubble beds equals better recovery potential, but depending on the little sea cucumber, depending on what's binding and growing on it. And one thing that came out of the workshop is that interventions that stabilise rubble but also provide vertical relief. So in this picture, the stabilisation structure to the left is a grid which is just pinning down the rubble. The one on the right is also pinning down the rubble, but it's got that pyramid which is providing that vertical relief for corals. That can potentially give better success because it is lifting corals up out of that environment, which even if it is stable, we've seen that that could still cause some issues. And this is, the team. There's some members that aren't on the team any longer but have contributed significantly to this work. And I'm also highlighting Karen Aegland, who is my research assistant, who I've spent many, many months in the field with over the past 3 years. And she is looking for work at the end of June. So if you need a research assistant, she's a very competent boater and diver. So yeah, let me know. Thank you.
Time for one quick question, if there is one.
Thanks, Tanya and Tanya. Great talks. What do you think is the role of bioerosion in the whole story of rubble stabilization? You talked a lot about consolidation and rubble sizes, and obviously water quality is a key factor in breaking down rubble through boring sponges.
Yeah, I would say also probably the rubble beds that, like the ones at the Keppels, that are potentially stable, but they've got that overgrowth of algae, they're probably going to be the ones that are more bioeroded as well. So yeah, actually that's a good point, that even though they might seem stable, because of that bioerosion, it's even a worse story than expected. Whereas, in those exposed shallow environments, that growth of crustose coralline algae seems to sort of exceed that of bioerosion in that case. So I guess it's another factor that's sort of adding onto the story and pulling in extreme ends. Yeah, good question.
Thanks very much, Tanya.
Thank you.
Our final speaker, and I'm going to try really hard not to butcher this, Carmela Isabel Nunez Lendo.
Oh my God. Okay. Hello, everyone. Good morning. I am Isabel Nunez. I would like to thank you all to be here with me. It's a great honor to present my works with so many coral experts and restoration practitioners and also traditional owners. I did my PhD at the Future Reef Group at the University of Technology of Sydney. And today I'm going to talk about one of my chapters, which is about applying a multi-tray approach to evaluate success, in this case looking at carbonate batches and other characteristics beyond survival and growth. First of all, I would like to acknowledge the traditional owners of the land and sea country in which I did my research, and I'm going to try to pronounce this, the Jidinji, Kuganji, Irakanji, and Gugujalangji, and pay my respect to those leaders, past, present, and emerging, and also extend my respects to the traditional owners that are in the room. And well, as you are aware, reefs worldwide are suffering many threats. This image is from 2022. However, we know that this year we have a very big mass bleaching event worldwide. And so far, the Great Barrier Reef has suffered 7 events of mass bleaching. And we also know that frequency, intensity, and severity of marine heat waves is increasing. And when we have coral bleaching, this is how it looks like. The symbiosis between the coral, the animal with the algae breaks down. In this stage, the coral still is alive, it can feed, but if some temperatures are still warm enough and they don't decrease, then is when we start to see reef decay. So the coral die, and there is this microbial biofilm that starts to cover the skeleton of the coral, and then is when we start to see decay, when we are losing reef framework. So we are not only losing biodiversity, but also the actual structure of the reef. And when we lose the structure of the reef, we are losing also many, many ecosystem services, such as those related to tourism and recreation. Coral reefs, they play an important role in the biochemical cycling of nutrients. We also know that they harbor a quarter of the marine species. The coral reefs are also very important for coastal communities that depend on these food resources. And also these communities, they are very dependent on these reefs for the protection of their shorelines. And as well, we have a lot of, as you know, coral reefs are a great place where to find new potential pharmaceuticals for the future. And all of these ecosystem services and many more are currently projected to be declined. And not only these ones, but also the cultural and spiritual value of the reefs. I tried to find literature on this, but apparently it's evident, but it's not evident in the literature. And I work with communities in the South Pacific, and their connection with the sea and the reef is very important to them, and it still is not kind of acknowledged, and sometimes it's overlooked. And so all these situations have led to a new way of managing the reef nowadays worldwide. And so there are different kind of strategies. There are some of that are targeting at the global scale in the sense to decrease carbon footprint and also reduce the greenhouse gases to the atmosphere. We also have some strategies at the shoreline where they look more at how to catch this pollution and this nutrient through catchment areas. And more we have all this active intervention using different kind of structures and strategies. So we have coral tree nurseries, we have different frames, ropes. And so which is the grand challenge for restoration? So in my research was about evaluating how these interventions can sustain or restore ecosystem service. And so far, we only look, or many of us look, at survival and growth rates, which are very, very important metrics, but we need more. Because ecosystem service, many times, is not well captured in these two metrics, and therefore there is a need to bring new metrics. And how, when we intervene, if the ecosystem services is sustained, as I say, or restore, which is the long-term objective of restoration. As I say, survival and growth metrics doesn't give us enough information about the coral performance during restoration interventions, but also during the planting stage, and doesn't tell us all the information regarding future reef resilience and the current functioning of the reef. As well as they don't capture potential trade-offs between trades. And so therefore, this is why I advocate for the use of more trade-based approaches where we apply multi-trade analysis, looking at more traits, more characteristics beyond survival and growth rates. And my research took place in this context. There were Mars efforts, and still ongoing Mars efforts on the Great Barrier Reef, and they specialize in a technique that focuses on substrate stabilization through the Mars-assisted restoration system, or reef stars. And experimental design. So I'm happy because we are in Cairns, so this experiment took place here, just 50 kilometers off the shore in Moore Reef. And there were three sites. So we have the positive control site, which is a representative reef patch on this area. We have the negative control site, which is an area with rubble. This rubble was created in 2011 because Cyclone JC hit. And at the time of this research, which was 2021, so 10 years later, still this rubber patch was still there. And we also have the experimental site. So this is 2,000 square meters of area that was intervened. And there were 87 at that time reef stars that they were installed, and they were seeded with branching and coromboes and plating forms of corals, corals of opportunity that were found there. And there were 2 time points. I had access to the reef in February 2021, so this means 6 months after the installation. Due to COVID, we couldn't be there at the beginning, and then 1 year later. So the methods, I measured 35 traits. I will show some of them. We apply the reef budget methodology, which consists of different surveys. So we have benthic surveys, that very unique surveys that you have to measure every benthic class below the transect and measure the surface area. We have also where we look at all the benthic classes, corals, crustose algae, and other kinds of microborers. Then we also did fish surveys focusing on parrotfish, and we also look at urchins. So we also perform urchin surveys. Usually this reef budget is, they look at that, and it's very good methodology, but I wanted to look other characteristics to see if there were trade-offs. So I look at the skeletal properties of 3 dominant coral classes. So in this case was Posilopora damicornis, which was very common in the area, in the rubble patch and in the reef. We also look at Acropora intermedia, very dominant species in the area as well. And because Acropora intermedia wasn't in the rubble patch, I had to take as an equivalent, and this was a branching Acropora rubble, because there were no presence of Acropora intermedia there. And so we start with survival and growth rates. As you can see, I look at 3 different growth rates. They all grew, sorry. And we had 100% survival success. Wanted to say here that when you look at the growth rates, because we arrive at 6 months later, we didn't catch this big increase in growth rates. This is how tricky is growth rate. Depending on what time you arrive, you can catch a big growth rate or a shorter growth rate. So this probably was higher at the first 6 months. And this, of course, we assume probably is because of the optimal reef environment where, of the restore site, where the reef stars were installed. When we look at coral cover and rugosity, so here you have positive control, which is the reef, negative control is the rubble, and E is the experimental site or reef stars. So again, we can see there was a higher coral cover in the restore site, so the big bar in the first graph. We also have a higher rugosity in the restore site. And again, we assume that this probably is because these reef stars are doing well in the restore site. I'm going to go quickly. But when we look at the carbonate budgets, okay, if we look at the middle image, we have a gross carbonate production at the reef stars. However, the gross bioerosion, was similar across sites. And this, if you go to the first image, you can see that the net carbonate budget was positive in the restore site and negative in the rubble site, meaning that with this intervention, we could regain this carbonate budget again. Then we look at the skeletal properties, and there I look at several skeletal properties, and one of them that I found a trade-off was hardness. And so I detected a reduced hardness in Posilopora damicornis in the reef stars, which I didn't detect with Acropora. And I think it's just because there are too many Acroporas, and Posilopora doesn't do well surrounded by so many Acroporas, but also the niche, the environment there also changed and is less favorable for Posilopora. Conclusion, here is the paper was published, if you want to check it. Carbonate batches, we consider this trait as a trait that is more aligned to ecosystem services, and we advocate for look at this trait when you are evaluating success of restoration. We also believe that, as you saw, the substrate stabilization through this technique increases carbonate budget on a degraded site that was already 11 years without showing any kind of recovery or very slow recovery. We also showed that this carbonate budget was higher on the restored area compared to the nearby reef, so the natural, healthy-looking reef. And we think it's because of competition between a space and a species. So in a reef that is already in a later stage and is well established, there is no room to grow. There is no space to grow, and there is more species competition. But also the life stage. We use, in the reef, you have very adult colonies that perhaps are putting more efforts in reproduction, not towards growth. But then in the restored area on the reef stars, we take fragments that are putting more energies in growth. So life stage or size also makes an impact here. We also find that this technique increased the rugosity, the complexity as well. And again, this is aligned with another ecosystem services, that is habitat provision for other organisms. As you saw, when looking also at other traits, skeletal traits, we can detect trade-offs, and we can refine the success of our intervention. And there are other many ecosystem services and traits that you can look at that I know that Mars is also studying this, such as invertebrate diversity, fish productivity. And lastly, well, to say that, of course, this intervention was in Moore Reef, so we need to be careful when giving recommendations, because one technique can work, another reef, it's different. But in general, I would say that this Mars substrate stabilization technique was great in promoting this reef accretion in a place that was shown that in 11 years didn't recover naturally. And so in this case, we can say that we have regained these ecosystem services, the carbonate batches that is related to wave attenuation. And so I would like to thank everyone for listening to my talk.
We got time for one question before lunch.
Thank you, Carmela. I'm really interested because there's a similar Mars restoration intervention in Indonesia, and there's been a few papers showing similar results. Have you compared yours with theirs? And the other related question is, they also looked at complexity as one of their ecosystem services, and also found that it had increased. And I was curious how you measured complexity or rugosity.
Yes, so the paper that you're referring about carbonate batches was recently released. So I published this before this was released, and they look at the long term. Mine was shown that in 1 year we regained this, so it's different approach. I look at the very immediate success, and they look at the long term. Both are good, both are showing that the carbonate batches can be regained. And there are other articles from Mars efforts which they look at other kind of traits, such as they look at the acoustics, they look at especially acoustics, I think, and also diversity of invertebrates. So they are looking at other traits. And the second question was? Rugosity, well, through this technique, when you do the transect and you are measuring each individual benthic class below the transect, you have a spreadsheet that you can add the numbers, and so it measures directly the rugosity. Yeah, so rugosity informs about complexity, but of course there are other traits that can also inform about complexity. Yes. Thank you.
Thank you so much, Carmela.
Thank you.
Thank you to all our speakers, and now it's lunchtime.
we're starting on 1 o'clock. So just as, are we ready to roll? So just as a quick introduction, so I'm Jim Hicks, I'm the acting RAP Program Director. So, and just a bit of my background. So I grew up on a dairy farm, almost 2 hours away from the coast with limited opportunities, but I always knew I wanted to go fishing and scuba diving / getting paid to go fishing and scuba diving. So I did that, actually did commercial diving for AIMS back in the early 90s, but met my wife 30 years, or married my wife 30 years ago next Tuesday on a cruise ship. So I've pivoted away from field trips to, because we're both working on ships and it was no fun, so pivoted away and I've pretty much been doing policy work ever since. So I should say I'm normally on Canipa Island or Russell Island in Dangambalan country. So I just want to extend acknowledgement to traditional owners here in this country here as well, and pay respects to the elders past, present, and the future people that will be, hopefully taking and lifting some of that load into the future. So my background, like I said, I'm a bit of a policy wonk now, and I've had a bit of experience in raising cash in sort of structured ways and being responsible for about $500 million worth of funding going to commercial fishing in Queensland through various mechanisms, either through the government or through donors. So it's nice that we're actually looking at some more structured ways, because you can't always rely on government to pay for big activities that need to be done. So just like to introduce Cedric, the Executive Director for the RAP program. Thank you.
Thanks, Jim. Hi, everyone. And I've introduced myself yesterday, so I won't do that again. I will certainly not go into my marital history. So, okay, I can see it that way. Look, today I'll be, okay, that's great, that's showing here. So today I'll be spending a bit of time telling you of the work we're doing around biodiversity credits as essentially exploring new ways that we can structure financing to really look at the scale issue. So you've heard around the conference, this issue of how do we take the technologies or the interventions or anything we're doing on a smaller scale, how do we take that to the large scale that we need for many of these reefs. And that will require, yes, technological advances for sure, that will require people and partnerships, but it will require funding. And that can make a big difference. Is that the thing we're using? Okay, the green button. First of all, I'd like to pay my respect to the traditional owners of the land we're meeting on today, but also all the traditional owners that we work with. It's a huge community, and it's a fantastic community we're working with all along the GBR, and I'd like to pay my respects to the elders, past, present, and emerging leaders. The global context for us is, you might have heard, I'm sure you have, in December 22 now, the Global Biodiversity Framework was agreed. At COP15, which is the Convention on Biological Diversity, COP15. So not your COP on climate, the COP on biodiversity. And it had some pretty clear objectives there and really provided some, I guess, structure for us to look at how we can align the work we're doing in conservation. That's another way to present it. That's not my slide. It's a great slide that talks to the actions that are in this global biodiversity framework. And they can be split between the ones that have a time horizon, 2030, some that are longer term. But essentially, it's around conserving, avoiding damage, safeguarding, and acting. And for us, I would definitely encourage you to have a look at some of these summaries around the Global Biodiversity Framework. It's actually quite transformational, and it was a real achievement. Now we're really into the practice and how do we implement that. The actions that really are relevant to us, they all are, but these ones are particularly relevant to the field we're working in here with coral reefs. There's the restoration and conservation of 30% of land and seas. Everybody asks, what about the other 70%? What we mean here is a target for the global community to try and achieve some significant change in the way we're dealing with this. There's reducing the climate change impact, of course, but also looking at how is sustainable management, I guess, of all the resources that we have here and that we're relying on, as well as essentially mainstreaming biodiversity into all sorts of policies and practice and procurement and accounting and all the things that you need for the global business community to actually embed that, as well as government embed that in their decision-making frameworks. So Another key aspect of this framework was the call for businesses to monitor and disclose nature impact. Interestingly enough, there were many business groups that actually asked for this to be mandatory, but it was not signed, and that was a negotiation discussion. But businesses are actually pushing quite hard now for this to actually be systematic, because the businesses that are leaders are penalized by doing these things, whereas if it's a common ground and everybody has to do it, it's a much better place. But the idea of monitoring and disclosing your nature impact is the first step before you can start addressing these impacts. The case for investing in nature, I mean, maybe you all know this, but it's striking. The World Economic Forum has done analysis of how much of the world's economy and GDP, if that's one indicator, but how the world's economy and well-being is actually relying on the services that nature provides. The point is, it's been taken for granted up to now, and still in many places today. There's a 69% in decline on average in species population since 1970. I mean, you can find other stats, but it's not looking great, and that's because we haven't really acknowledged the impact we have through our activities. And they've estimated collectively, who knows, that numbers vary by, $100 billion here or there, but it's $700 to $900 billion in US dollars to address the financing gap that is required if we want to achieve the actions that have been identified in this framework. And that's annually, okay? Just bear in mind, though, that it's about as much as we providing globally per year in subsidies to industries that destroy nature and pollute. Just so you understand that it's actually not a huge number economically speaking, but it's where we are now, it's a huge gap. If you look at the life below water, so the Sustainable Development Goal 14, it's even worse. It's estimated it needs about $150 billion a year to achieve the goal that has been set there, ignoring the Global Biodiversity Framework, just the goal under the SDG 14. And between 15 and 19, we've had a cumulative effort of about $10 billion. So we are way off in terms of the amount of financing that is put into these activities. Now, the good thing is this global biodiversity framework. So if you think about climate change and greenhouse gas emissions, the first thing that you need to do to address the issue from a business point of view is to actually account for your emissions. And once you start accounting, you can also start setting targets. Once you set targets, you can start developing instruments for companies to meet these targets. So the same process is now happening in nature. In fact, the same groups that are now developing the same for nature. So the task force on nature-related financial disclosure is the reporting side of things. You need to know what your supply chain does. You need to know where your products come from, and you need to understand the impact you have, not on carbon, on biodiversity. Then you need to set targets that are science-based. As an organization, if you're saying, well, I want to be nature positive, what does that mean? And what do you need to achieve through your supply chains and your products to actually, and your business operations to change that? Already 320 major and smaller companies have signed up to this framework, so it's actually happening. And we need to think very hard about how we contribute to that movement in terms of directing, as you've seen with the SDG 14. Let's make sure not all of that goes to land. It's very important, but there's a lot we can do in the water. Biodiversity credits, which I'll talk about today, are one way to do this. And I'll explain a few reasons why we think it's a powerful instrument. But to start with, I just want to give you a bit of an idea of the overall concept. So first of all, it's not an offset, and there are biodiversity offset policies out there. Could a credit be used as an offset in the future? That's a policy issue. That's a decision that governments can make. The point is, it's not the same as your biodiversity offset strategies that you have in New South Wales or in Queensland. They're already there. They're different. This is not designed to give you a right to destroy something and replace it. That's not the purpose. But they're verifiable, quantifiable, and tradable instruments or assets that reward positive nature and biodiversity outcomes. The concept here is that, no way I'm going to point there. So if you look at the biodiversity state, let's imagine we're about here, and that's a positive outlook. We're going down, and if we do nothing, this is business as usual, there's a pretty good understanding that we are actually on the downward trajectory with biodiversity, if you take biodiversity as a whole, which has a whole lot of way to ways to be defined, but that's what it is. If you look at conservation and restoration, really what we're aiming to do is to buckle that trend, to change that trend and to get back to a sustainable place. But it's not where we should be, right? And this concept that we can restore where we are, I think there's an understanding that unless you transform your production and consumption systems globally, that is really, really hard to do. But that's the space we're operating in. And for us, that area under the curve is the value, right? You're not selling the trees, you're not selling the species, you're not selling the animals to anyone. That's not trading nature that we're talking about here. What we're talking about here is to quantifying the impact that any project can have and how that impact can then be sold to people that want to deliver on their targets. So I'll go in more detail over the next slides. I'll give you an example, and that's very dry, but it's also just a practical way to look at what it could mean for us on the coral reef. And don't take that as the GBR. I've made it a little bit less specific to the GBR on purpose. But if you think of a reef governance environment, you have a reef governance framework. Within that, you have a reef manager that has to set activities and interventions, target locations and objectives. The best way to do that, the best practice, is obviously to have that done with science and R&D. We've heard that over the course of the symposium, to inform the actions, to develop the actions, to inform them, and to inform where you will have the best impact and how you might monitor and model that. Once you've got that, you obviously have people delivering projects. So they can be an overarching entity. It could be, the reef manager can be the one delivering this. But the idea generally is that if you want to achieve scale, you will have to work with a whole range of partners, from traditional owner enterprises, cooperatives, SMEs, all sorts of groups that can deliver the activity. The point, though, is that's what you want to do, and that's how you're going to do it. You do need dollars. It doesn't matter. And especially with biodiversity, the dollars need to come up front. All of the work you do in biodiversity has a long payback. And that's one of the differences with other activities, is that you need to put a lot of money up front to deliver the benefits. The challenge with that is someone has to take the risk. And it's either a grant from government, or it's impact investors that provide money at a lower cost for people to do this work, and they expect that money back with a return. Nobody's giving free money to anyone in this context. The impact investors are expecting a return, but they want to invest in activities that are positive. And you can have blended finance model. It might well be that it's a mix of government funding, grant-based models with private investors. Essentially, once you've got that money, you can deliver the activities. And for us, it would be delivering some positive coral reef and biodiversity outcomes. So here we're talking restoration, adaptation, protection, any activity we think can generate a benefit. What needs to happen, though, and that's pretty much how we do things today, right? It's not very different, but we're not really providing any return to any investor at the moment. We're essentially delivering activities to try and make a change in the system. The difference with the biodiversity credit is that you agree independently on the methodology to quantify, report, and verify the benefits of your action. So when you say, I've restored this reef, what does it mean? And what does it mean, in fact, to someone restoring the reef on the other side of Australia or in another country? For an investor, what does it mean? And this issue of consistency we'll discuss in a minute. But you have a methodology that needs to be independently developed and peer-reviewed and agreed. And that's essential that that methodology supports the right outcomes. If you've got that and the audit process is attached to that, then the outcomes of your projects can generate credits, and that's where they get generated. Essentially, the methodology says if you achieve this, this is how it's translated into a tradable asset called the credit. Again, at that point, a lot can happen. What is sure, though, is everything I've seen to date around the world around biodiversity credits assumes and requires a very strong understanding of how this will be shared with traditional owners in terms of ownership, whether they call indigenous people and local communities or First Nations. The concept here is that there needs to be a sharing mechanism built in the credits. Nobody wants to see these credits happen without some clear objectives in this regard. And that's because they've learned from the carbon credit market, where you could see some real abuse of local populations, and people got really screwed essentially in some of these areas. What you want to do, though, is to sell these credits. Now, they're not sold as a commodity that you just keep selling and speculating. The goal here is for someone to, what we call off-take this, to say, I'll buy those and I'll retire those. And the concept here is that, let's say you're an individual and you have money and you want to achieve something on the reef. You can either give money to a project proponent and say, hey, can you go and do this? Or you can buy the credits, which you know have been independently verified. You know they've delivered an outcome, and they are doing your due diligence for you. And you buy these credits because you know that they will deliver benefits that have been standardized. The dollars go back to your delivery, and to be fair, this part is really the policy setting. It can be quite complex as to who owns the credits and who sells them and where the dollars go, but ultimately, the dollars need to go back to the people that have in some way done the work so they can pay back the loans, essentially, that they got to do the work. And that's why your impact investors get paid back, either in credits or in dollars, depending how they set up their investment with you. Dollars can also go to your local communities. There's no reason why you can have inbuilt in your methodology an agreement as to how benefits now and benefits in the future are shared with the local communities. So there's a lot to unpack in here, but that's essentially the mechanism. Now, it sounds complicated, but once you're on the other side of this, when you're raising money day in, day out, and Theresa will talk about finance after me, there's a lot of benefits to this for scale. So the first thing to say is that it's transparent. It's really important for us to be able to standardize the outcomes and the verification. The reason for that is if you open your internet, you'll see people saving the reefs all over the world every single day with a new technology, a new project, a new method. I guarantee you, you will not see anything that talks about the long-term impact or the success of the project really long-term. There are a few exceptions. It's really rare for people to go back and talk about the outcomes of the work they've done. That's not how the system is geared at the moment. So for us, a transparent way to standardize the outcomes verification is really important. It's a tool that projects should use, and we think it's a tool that would really help investors to understand where to put their funding. And the fact that the methodologies are peer-reviewed, that they evolve, that they're subject to transparent assessment by the global community is really important. So it's not me telling you, invest in my project, because it's going to be much, much better, believe me, and I'm going to show you a very complex set of statistics around the data I've generated or not much. Here we're saying, let's just agree how we monitor, verify, and agree that it is contributing to what we're trying to achieve. The alignment is really important because if I tell you it's a great project, but you're a global company trying to achieve the global biodiversity framework targets, how do you know that it's aligned? So when we design this methodology for credits, we can also make sure that it aligns with the standardized expectations, I guess, from the global biodiversity frameworks. So a company saying, this is my footprint, I'd like to go above and beyond and manage this, but I want that obviously to be aligned with the global biodiversity targets, otherwise I'm missing the point here. Well, if you can do that with your methodology, you can align that. And it focuses the priority on areas that need it the most. The scalability is very important. That's really the main game for us. To give you an idea, and maybe Theresa can talk to this, but every donor we speak to for every project, when we raise private funding, we have to explain the impact of this project. We have to do due diligence. We have to do reporting. We have to have a special framework for every donor. Whether it's $100,000 or $100 million, we have to put something in place. The fact is, it's not 100 million. This small investment, when you look at the scale of what we need. So if you think you need to multiply by 10 or 50 the amount of investment, there's no organization, no NGO that has the capacity to manage that type of demand. So this standardized due diligence process, removing that project by project due diligence is really important for us. Investors will still want to know where the money goes, and you could use modern technologies to report on that. But you want to get away from that very slow and very high transactional cost of doing the work, of raising money. And finally, there's equity inbuilt in this. If you design the methodologies right, it's not a case by case. It's inbuilt that these things will be shared with the traditional owners or your local communities. Sure, there are risks. We've all heard about the carbon credits. We've all heard about this, and you'll hear a lot about the risk. They're there. There's no doubt. But it's very confusing as a space, and that's why these organizations you see on the right are really working to try and avoid the pitfalls of the carbon credit market where it was a wild west and it ended up being really confused, and now they're trying to realign all this. And there have been some bad stories. I think generally these organizations are working very much at the high level of principles around transparency, integrity, equity, and inclusion. But they also, as I said before, really very much building into these the local community angle and the First Nations. And then it's just down to the safeguards. What can you do and what can you say? If you're a company that has invested in the reef, can you say, you know, I've saved the reef? Well, no. But that's the greenwashing that people are worried about. But the challenge with this is every time we raise greenwashing, we also push companies down. The ones that want to do the right thing are the ones that get hammered. So we need to find a way to build confidence. And our view of this is that we need to, and I've got to say it's already happening. There's already plenty of biodiversity credits out there that are happening that are, some are dubious, some are great, but we think what's missing here is the scientific work that needs to happen behind that to provide the integrity. It starts with that. It doesn't, you don't do that afterwards. It starts with the scientific work. So we started a project, and that project is funded by the Reef Trust Partnership, as well as the L'Oreal Fund for Nature Regeneration. They're taking a risk here. They're saying, hey, we would like to see a biodiversity credit or methodology developed for corals. The way we're approaching this, though, is, well, by having lots of people. Some of the culprits are here in the room, but we've assembled a team led by Ken, led by AIMS, but it involves UTAS, JCU, and UQ. But the idea here is that we want to essentially develop a robust and science-driven biodiversity accounting methodology. To start with, let's not even talk about a credit. Let's just talk about how we link the corals to the biodiversity value they provide. And then with that, we can pilot it as a methodology. We can start looking at how that could generate a unit that we can trade. And we want to look how these models apply, the socioeconomic models then apply to this. So we can relate that to the value of ecosystem services and cultural values. Where it fits in ARAP, it fits in alongside the R&D program, the pilot deployments. We've got this little project that will use the pilot deployments as a platform to test the concepts. So we have the work at AIMS within ARAP with Ken, and we've got a person at GBRF that will be our nature markets lead doing all the work around policy settings, etc. But essentially, I won't go into the detail of this for time, but it's essentially evidence-based, developing indicators, have the right modeling and monitoring frameworks to predict the benefit of your work and then verify that it's happening. And have that as a coral biodiversity accounting method. And on top of that, there's a methodology to turn that into a credit. The value of this for us, it doesn't matter that a credit eventuates. I mean, I want it to eventuate because I can see no other way for us to scale the finance, but let's put that aside for a minute. The value of that work is really important because for us, it will start linking the work we're doing on the ground to the habitat, the species, the modeling and forecasting, and the baselines we need for demonstrating impact. And that can go into a coral biodiversity credit methodology, bearing in mind that after that, you need the policy and regulatory frameworks. You need the benefits sharing arrangements. You need the management objectives to fit in. So it's a very complex space. It will take time. But the work that we do, scientifically speaking, can serve with the rhino bonds. You might have heard about that. It's a concept where, you know, if you do work on the ground to protect the rhinos, you can get cheaper money to do your work. So it's essentially philanthropy helping the financing sector invest in these activities. But the bottom line is the same. How do you demonstrate that you've made a difference on the ground that is sustainable? You can also do that with Niue, which is an island state that has actually now released the concept of ocean conservation commitments. You buy them. There's a price to them, and you buy them, and when you buy those, the state commits to protecting a certain area of their reefs and their marine system for a duration. And that's, again, we get questions from everybody, from the World Bank and others calling us and saying, hey, you're doing work on the biodiversity stuff with corals. How do we know whether the activities they've committed to work? People don't have a framework to assess whether it's working or not. And that's why we're saying, let's do the work. The instrument is a second issue, but let's do the work. For us, very briefly, we see corals very much as the rainforest of the ocean. I know it's very catchy. It works with a lot of people. I'm sure within this room it's a little bit, you know. It's borderline. But essentially, the idea is that, you got the trees, the habitat. The habitat is the point here. You got the trees, the habitat, and that supports a whole lot of biodiversity. It's simplistic, but it is the way we can link our activities on the ground to biodiversity. Same thing with corals. They provide a habitat. They provide a habitat for a lot of species. And we know that it's complex. There's hundreds of thousands of species, and the coral and the fish, they make up only a fraction of these. And we don't know most of the species. That's not the point. Nobody is saying biodiversity is the cumulative quantity of every living thing in the system. That is not the definition here. What we're focusing on is understanding how the coral geometries and properties link into the relationships that essentially help us understand the scope of a particular reef to support biodiversity in space and time. And that's all an investor wants. They want to know that what they've done will make a difference to the biodiversity. They don't need to know the absolute answer on biodiversity. They want to know it will make a difference. And we build on all the data. We have one example, for example, is the refuge. We know they provide the habitat for fish. Can we actually relate that? Can we build in our models some measurements or some understanding of how the reef is faring and how our activities might change this aspect, for example, of biodiversity? We're only at the start, and Morgan, in typical Morgan style, just poured like a cubic meter of cold water on us at the first meeting, and we're all scared about it now. But the point is, there is value in doing that work. And we know it's hard, but we need to do it, and we have the data and the collective intelligence to do it. And we can then link that to the various species and the benefits they provide in terms of the biodiversity. Now, most of the schemes, and I did the last couple of slides, most of the schemes around the world that are being looked at the moment are agreeing on the fact that it's an extent multiplied by condition sort of method. You need to know how much you're doing in a spatial sense, and you need to know how that affects the condition of that environment. In the condition area, it really depends on your ecosystem, what you consider the right metrics for this. If your focus is on an iconic species, like the rhino, it's going to be the number of rhino and their health and, the baby rhinos or whatever, I don't know. But the point here is for coral, it'll be a different set of metrics that we want to rely on that are a fair representation of the benefits and the ability to support biodiversity. Significance is important because that's what links you to the global frameworks. The risk with these things is that people will buy a whole lot of very, very cheap credits that are restoring trees or things in areas that absolutely don't matter. And that's the worst thing. So the significance of the area you work in is important. For us on coral reefs, they're highly significant, so it's not a question. But for some other ecosystem, it's something that needs to be looked at. And so we can look at the areas. There are a lot of tools, the Coral Atlas, and a lot of work we've been doing. Renata has been speaking this morning about what we can do with monitoring. There's a lot of stuff we can do to measure extent. So for corals, that's going to be actually quite easy. The various blocks and things you're going to bring into that metrics, we will need to make sure we can link that on one side to the modeling, on the other side to the monitoring. And it needs to be cost effective. There's no point designing a monitoring framework that nobody can implement. So we'll need to think of trade-offs and be able to use modern technologies and automation, for example, to make that easier and faster. I won't go through this, but just pointing you to, there are a few draft frameworks for biodiversity credits or nature credits or certificates, whichever one you want to call it. It doesn't matter. It's the same concept. There are a few frameworks out there. What I just wanted to say here is that the accounting is only one part of this. It's measuring conditions and tracking conditions. But there's a whole lot of stuff you need to do to justify why you could even qualify for a credit in this context. And you also need to really deal with the baseline. And I'm going to stop here because we absolutely don't have a strong idea how to deal with this. But in a climate change context, the baseline is quite significant. It's going down. So what you're trying to do is not to go from a state and go up or try and keep it. We're actually trying to prevent the losses. There's a lot of value in that, obviously, otherwise we wouldn't be here. But the challenge is, how do you manage that baseline without gaming the system? Because in the carbon credit, there's been a lot of that. People have had artificially inflated baseline and therefore generated more credits where really the actual absolute change has not happened. So we're very conscious of that. So over the next 2 years, we'll work on that and we'll publish a report, and we're very keen to engage broadly on this methodology in the future. And we'll apply it to some of the pilots we're looking at. So I'll stop here. I'll thank everyone, especially Ken here in the room, for the work we've been doing to date under our own steam, and now with the project that is fully funded. So thanks for the Reef Trust and for L'Oreal for funding that.
It was a cunning plan. He used his full 30 minutes, so we're actually out of question time. So
it's only 25 technically.
But. Oh, okay. So we didn't say that late. I'll just give people, while they escape, if they want to escape, just introduce Theresa Fyffe, who's actually taking over from Anna Marsden today. Talking about funding for scale and impact. So over to you. It seems to be working. So.
Excellent. Thanks. That's always a good start. Fabulous. I'm really excited to be here today. So many people in the room and just in the conference in general that I haven't had a chance to see face to face since before COVID. So it's an absolute delight. Love to just start by acknowledging the traditional owners on the land that we meet today, and also acknowledging any traditional owners that are with us in the room here, and all of the traditional owners that work with us both in Australia and internationally. Just incredibly grateful for the wisdom, the partnership, and the work that we're able to achieve together. So today I'm not Anna Marsden, so I'm Theresa Fyffe, and I lead the conservation portfolio work within the foundation, but I do spend a fair chunk of my time actually in the fundraising space. So I'll try and do Anna's presentation justice today. So just wanted to start, I don't think I need to give any background to the foundation. You all know who we are and what we do. But since 2000, we've secured over $440 million in investment. Now that is not just direct cash. So on our website, we've got our collaborative investment strategy, and it describes how we talk about our investment, and we talk about co-investment. So that's actually funding that comes from all of you, from our partners who co-invest in the work that we fund. It comes from corporates, it comes from individuals, and it comes from philanthropy. 350 million has been secured in the last 5 years, and that has been largely off the back of the Reef Trust partnership. And neither of those two figures include any of the government money that went for the partnership itself. We're finding that there's a building of momentum for investing in oceans, particularly in the philanthropic space. And interestingly, I think there's a number of factors that are driving that. One of them is undoubtedly that, you know, every week there's a story about another incident, either a cyclone, a bleaching event, or something impacting coral reefs. And so there's a crisis, and crises, you know, it's devastating, but it does have an impact often at mobilising investment. The second piece is we've seen a real shift in donors that historically played in the humanitarian or in that kind of social impact space. And they're really seeing coral reefs and oceans now as a humanitarian crisis. So what that means is that there's a lot more donors out there that are not just in that kind of purist, if you think about sort of Gordon Betty Moore, those really traditional kind of ocean funders. You've got much more non-traditional funders that are wanting to contribute funds to the cause. And it is welcome because I'm sure most of you know, but SDG 14 receives the lowest funding out of all of the Sustainable Development Goals. Collaborative investment strategy, I mentioned, we have all of our targets on our website, but under the government grant, we had a target of $357 million. A big proportion of that is co-investment from partners. But what I wanted to really show was, I guess, how it spread out across the components, because it didn't land, I think, in necessarily how we thought. The only area that we weren't able to date, generate private or corporate funding from has been the Crown of Thorns starfish space, but we continue. There is general interest in the innovation space, but when it comes to actually killing creatures, it's a little bit of a more difficult value proposition. But if you have a look at the leveraged funds and you look at something like in the community reef protection space, you know, basically the $10 million in that grant's returned $39 million in largely co-investment and some private donations. But a lot of that, the way in which we calculate the co-investment, we've got set figures that people can use, for example, for volunteer hours. So it's quite a robust framework. And I think we all know inherently that in community, there is a huge value add and there is a huge investment that community makes, but I think it's rarely acknowledged. So to kind of see that the area in which we've actually got our highest return is coming through that community space. Philanthropy. So we're seeing the gift size increase and really think that again is driven by multiple factors. It's driven by the fact that we are seeing the ocean and the coral reef cores becoming more of interest, and there is no doubt that philanthropy is growing. So the number of philanthropists globally and the amount of funds that they have to liberate each year is enormous. What they are missing for the most part is really large pipelines of projects to invest in. If you want to invest $100 million or $500 million or $1 billion, that's a big pipeline. And as Cedric said, there aren't a lot of NGOs that are playing in this game at the size, have a pipeline that can actually match that. So that's a challenge that we have. There is a lot of investment, but how do you actually unlock that investment? The US, again, it will be unsurprising. They have a very strong philanthropic giving culture, but again, they're extremely wealthy people is growing in the US. Some of the major insights, and some of this has shifted quite a bit. So we're finding that collaborations are what donors want, and we are more and more being asked when we're asked to put forward a proposal to a donor. They'll say to us, okay, well, we're already funding this work in reef restoration with this partner, and so you need to create a consortium and come together. So we're really seeing that competition isn't an attractive proposition to these investors. They really, really want to see collaboration. There's a shift from MPA, just funding MPAs, and a lot of, again, those donors that have spent the last 30 years just funding MPA work are now funding more in the adaptation and intervention space. No surprise, First Nation and Pacific projects are growing in attraction, and it's because there's recognition that no one knows the local context like local communities and First Nations people. And if you want to get enduring outcomes from the impact and the work that you do, it has to be embedded within local contexts. And technology and innovation, it remains dominant, and it's been a steady investment stream for a long time. Corporate partnerships, so for those of you that knew the foundation before the RTP, so we've been around for 25 years, our primary investment stream before the Reef Trust partnership was actually through corporate partnerships. So it's been a big part of our overall funding strategy. They are, what we're seeing in the corporate space is we're seeing a shift away from things like investing in sport to actually investing more in causes that align with their ESG priorities, not in terms of delivering on the ESG priorities. And there is a very strong line that needs to be drawn, and Cedric mentioned the greenwashing issue in his talk. You know, there have now been companies prosecuted under the new greenwashing rules, and so it's driving a really favourable shift in terms of corporates understanding that they need to make a very significant investment into something that is going to deliver meaningful impact, and they need to be prepared to take a back seat in terms of the kudos and the communications that comes with that. And so, you know, we're seeing less and less, which is great, of corporates that are expecting to have their corporations being endorsed by not-for-profits, but rather talking about the work and the partnerships that are happening and the impact that they're delivering. Again, I've covered off on that second piece. The Great Barrier Reef is very, very a very hot property in terms of investors, and so this is coming through stakeholder and shareholder surveys that corporates are doing, where they're kind of saying, you know, here's a whole range of different environmental causes. What are you finding as the most important? And time again, the Great Barrier Reef comes up first. Yeah, and I think this last one is interesting. We're trying to get the balance right here, because if you look at something like CSIP, the COTS Control Innovation Program, or RRAP, clearly you need to have a really strong R&D base in order to get meaningful deployment. And so we've been working, I guess, in an education context with donors to be, you can't just go and fund the cool stuff on the ground, because if that's not evidence-based and embedded in strong science and in local contexts, then it's not going to be enduring. And so we're trying to kind of set up a model by which we encourage our corporate partners to invest in both the deployment and the R&D and the locally led traditional owner engagement activities. Just going to close with 3 case studies. They're all quite different. And Cedric mentioned the Moreover partnership and the L'Oreal, the Fund for Nature there. At the same time as we were negotiating that deal for the biodiversity credit, which did take quite a long time because working in that biodiversity credit space, it's so new. And so it was the first deal that they had sort of done, and certainly the first that Moreover had undertaken in the marine space. But simultaneously, we were talking to their Garnier sort of team within L'Oreal, and were able to have, as part of the funding, they fund the biodiversity credit. They provide a chunk of funding for some R&D, but then there's also a clip off the ticket of every product that's sold that then goes into reef restoration more broadly. You might have seen that. That was quite a big activation, so all the Coles supermarkets had that for quite a while. The McLaren Racing, I mean, those of you that are in the RAP team will know this well. This is, has become, I think, a really high-profile one. The backstory is that there was a Zac Efron television documentary about reefs. It had some work that was showing corals being zip-tied with plastic zip ties onto structures. And so we literally had the head of McLaren F1 send an email to our info@Barrier Reef email address saying, why are you using plastic zip ties on the reef? We've got better products than that. And that started a conversation internally between GBRF and McLaren. And where it has landed is that McLaren has a program called Accelerate, and that's really looking at how do they harness the power of their incredible supply chain to drive costs down in whatever process it is that you're looking at improving. And so we've asked them to have a look at the semi-automated aquaculture processes from within RAP and look at where are the cost efficiencies and looking at kind of driving down the cost of producing a single coral kind of tenfold over the next 2 years. So there's been some great media that's been generated. Both Cedric and Anna were out on the reef with Oscar Piastri. I don't follow F1 at all, so I had no idea, but apparently people tell me that was a big deal and that people were falling over themselves to actually want to be on this particular famil. But it's just, you know, what I'm trying to show with these examples is that there's more than just cash investment. So you get cash investment, you get introduction to, you get the know-how, you get introduction to network, but you also get channel, and the channel to amplify messaging, which is really, really important. They can reach a whole lot more people than any of our organisations can. Forex, kind of changing tack, the support our Reef Sink a Schooner initiative. So, you know, love it or hate it, Forex is a Queensland icon. And so it's been a fantastic partnership, a really, really great partnership. And it actually started through our water quality area, and they're funding a project looking at automated irrigation systems. And it was a really interesting donor journey because we were kind of talking about they really wanted to have a partnership profiling farmers and the great work that farmers are doing in terms of improving the health of the Great Barrier Reef. But it wasn't until we actually had some conversations with some farmers and they were saying, you know, this irrigation, this automated irrigation system is actually going to change our life. Because our manual systems mean we've got to get up sometimes twice a night, like actually down to different parts of the paddock to change over our irrigation system. And so it's become kind of a mental health and wellbeing issue. And that really resonated. They were like, oh, wow, this isn't just about, you know, improving productivity of farms and improving outcomes for the Great Barrier Reef. We're actually improving the wellbeing of our farmers who, you know, backbone of the supply chain in Australia. So they've done loads and loads and loads of marketing, and again, you would have seen that promotion coming out on, and it was great. And the farmers who often see themselves as being vilified in terms of the impacts that they've had on the reef, where individual farmers that are just doing over and above could actually be profiled, and be profiled by a company that resonated with them. That was really, really important. So right now, there's a 50 cents a schooner on for a current fundraising opportunity. And I'm just going to end on this, and I'll leave this up for people to have a look at. It's actually more to do with community, much more about community sentiment than it is about fundraising. But we find people really interested in what does the everyday Australian kind of think about when it comes to coral reefs and the Great Barrier Reef. And just at the highest level there, you know, where we've seen the shift. We did a sentiment survey back in 2020, 2021. And people knew that the Great Barrier Reef was under threat, but they couldn't actually name the threats, or when they did, they were kind of random things like sunscreen or things that really weren't in the top 5 of reef threats. Going back in 2023, and this included focus groups, it was only within Australia, but it was Australians generally, Queensland, and then reef kind of heartland. Every single one of the groups could actually name specific threats. And so it kind of showed that that awareness is getting through. They understood the urgency. Collaboration and action is what gave them hope. And a number of researchers within RAP I know have had a look as well as that same thing. You want to motivate people. You have to give them something that they can do. How can they be a part of it? And you also have to show, talking about bleaching, what is all the things that we're actually doing to try and move the needle. And lastly, just that in all of the consumer surveys that we did, science was still held up really, really high. And that hasn't been the case throughout. You know, we know there's some challenges in the water quality space, and you know, some of that has been challenged. But the everyday Australian sees the science, loves the breakthroughs. So that's kind of the fundraising stuff in a nutshell. Thanks, Jim. Did I use all of my time? Did I use all of my time?
You certainly did. So we have an emerging trend here. So we do have time at the end where we might save up some of the questions from the speakers. So, sorry, the next speaker is Cabral Reniel. Sorry for getting your name probably badly pronounced. But so financing marine protected area, it's actually something close to my heart.
Thanks. I'd like to acknowledge the traditional owners of the land and sea that I work in. And so now I'll talk about a different type of mechanism to finance conservation, which is something different, and you will see that in the following slides. So marine protected areas are areas in the ocean where fishing is regulated, and it helps restore biodiversity and enhance nearby fisheries. To date, MPAs cover 8.2% of the global ocean, 3% of which are fully or highly protected. So the dotted lines there, that's the trajectory of marine protected areas, and the big blue point there, or dot, that's the current MPA coverage. With respect, like comparing it to global targets of SDG, Sustainable Development Goal, and conservation of biological diversity, of 10% and 30% protection by 2020 and 2030. We're still lagging, so there's lots of work to do there. Also, not all current MPAs are effective, and a major bottleneck is sustainable financing. So MPAs, as we all know, improve biological conditions. Scuba divers and snorkelers are willing to pay more for better diving. So the goal of this talk and my research, or our research, is that we'd like to evaluate the potential of a well-designed user fees for marine tourism in MPAs to finance conservation. So I will present 2 studies. One is a global study, which is the global economic potential of MPA tourism. So combine MPAs with user fee, how much revenue could you generate? The second one is a study conducted by my student on the willingness to pay of divers in the Great Barrier Reef. So more of a scale down. So research questions that I like to pose are the following: how much revenue can we generate from a well-designed user fee in MPA's scuba dive tourism? And the second one is, what are the drivers of willingness to pay of the GBR, in the GBR? So the second one is important because we want to know, like, for example, if there's changes in fish abundance or coral cover, how sensitive would be the divers and their willingness to pay, and the values, the demand for diving. So there's lots of implications for this second question. So in a nutshell, this is the method that I use for the global study. We, the team, assembled a database of dive shops, sites, and prices from thousands of locations globally. This is a lot of effort to do that. We also compiled a willingness to pay studies globally and synthesized like how much people are willing to pay for a unit of increase in coral cover, for a unit of increase in fish biomass, and so on. We also developed a bioeconomic model to test how much the demand, the number of divers will change given changes in ecological conditions. And also like the willingness to pay, how would it change given changes in ecological condition. I'm happy to chat with you about the method. For the result of the first study, for the first time, we've estimated how much dives are there globally. And we estimated that there's 50.7 million scuba dives are made worldwide each year, 65.3% of which are made in the ocean. So that bar figure there, or bar chart there, that's the number of dives per year in different countries. Number one is Egypt, Thailand, United States, Indonesia, Australia, Philippines, Mexico, Malaysia. So 50% or greater than 50% of dive sites are made in 8 exclusive economic zones, right? So only 15% of dive sites globally are currently inside fully or highly protected MPAs, right? 15%, that's an important number. And the total revenue from scuba diving is, we estimate it to be 1.94 billion US dollars per year. This revenue is just number of dives times price per dive. It doesn't account for the multiplicative effect, the hotel revenue that hotels or businesses get from tourism, dive tourism. So this is just the revenue by multiplying number of dives times the price per dive. And the consumer surplus, which is the satisfaction generated by divers. If you can convert that satisfaction into a dollar value, it's $2.67 billion per year. So we have more detailed data, like at the country level. It's spatially explicit, but I'm just presenting here like the global result. So the question is, what if we upgrade the protection status of all scuba dive sites in the world? Remember, it's just less than 1% of the global ocean are dive sites, and 15% are in fully protected area. So just for the sake of argument, like how much benefit you could get if you upgrade the protection status of all the dive sites. So what you will get is an additional 616 million US dollars per year, and divers will be happy. So there's like additional consumer surplus of $2 billion per year. And also I think hotels and businesses will be happy. There will be 32% more dives that will happen in the ocean. So this consumer surplus, this is not really a real dollar values, but you can use economic instrument to convert that into dollar values that you can use for management. So one idea is like a user fee. So if you implement, you upgrade protection status of all dive sites and also combine it with user fee, then you could generate $2 billion per year in user fee revenue without impacting the consumer surplus and the number of dives. So dive tourist operators will be happy with this, as well as you'll generate extra money for you to use in conservation, either protecting or helping protect those or manage those marine protected area, or you can also use this and other like programs, conservation program. So in summary, upgrading protection status of dive sites plus user fee can generate $2 billion per year, and the cost is about half of that. So for the second work, which is like more of a going through the Great Barrier Reef, we developed a willingness to pay study using a payment card method of contingent valuation. And this is conducted by my master's student and now my PhD student. We used we tested different attributes, coral, fish, and also the protection status, whether it's an MPA or non-MPA, and also varied the level of quality. For example, coral cover, low, medium, high. So that's the sample question. More of a showing low coral diversity, fishing allowed. What if you convert, like you see a change to high coral diversity and it's a marine reserve. So we have like 22 questions that will allow us to understand better or disentangle the drivers of willingness to pay of divers in the Great Barrier Reef. This is the study site, and we did online survey as well as paper survey. And in total, we have 170 samples. So the results for this work, so we asked 170 divers to rank attributes they value when diving. 5 is high, like extremely important, 0 unimportant. And water visibility is the #1 attribute that they care about, followed by fish-related attributes. Those, the last 4 attributes, turtles, sharks, and protection status, whether it's an MPA or not, and the absence of fishing, they're ranked low in terms of their preference. So we asked this just to verify whether the willingness to pay study matches their preference when they state what are they preparing. So for the willingness to pay study, obviously if all coral and fish attribute increase from medium to high, they will pay higher. So they will pay, willing to pay 28.11 Australian dollars, then followed by a fish-related attribute, and so on. So I'd like to point the 2 bottom results. So what do you mean by that? So we asked divers the same biological condition inside and outside marine protected area. One is just an MPA, so there's a name on it, and the other one is fishing is allowed, but essentially what you can see underwater is the same. And essentially you would expect 0, they will pay 0, but we didn't find that. We found that divers will pay 14.53 Australian dollars for the MPA name itself. So that's what we call the MPA name effect. It hasn't been shown empirically, and hopefully we'll release this paper soon so that it will add to the literature. The other one is we asked them like an MPA in the Great Barrier Reef versus in the Philippines. They also put some value to the, like there's a premium to the GBR, and it's the same, 14.26 Australian dollar. So we added questions that are, I think, interesting. For example, we asked them, would you prefer fishes or corals? Well, I would say that most of them prefer both, but some of them prefer really fishes than the corals. We asked divers whether they would prefer small or large, one large or many small fishes. Divers would prefer like many small fishes. I prefer one big fish. Then also we asked them whether it's like coral cover or coral diversity. So they prefer coral diversity. I think this is very important, given that, for example, it will inform what type of management action you would put in. For example, if their willingness to pay is highly sensitive in terms of fishes, then therefore your management action could potentially like target improvements in fish. But of course, that's how I would interpret the result. Other insights, among several insights, is the survey instrument has no significant effect on the result. So whether it's online or paper, it's the same result, which is great. Australians versus foreign divers. So we're comparing their willingness to pay. So Australians are willing to pay 16.4% more in terms of user fee compared to foreign divers. And the graph below, that's stating the purpose of the user fee increases divers' acceptance of user fee. So if you state that the user fee will be used for managing the reef or for rehabilitation, etc., so they would likely pay versus if you don't state the purpose. So how can we use these results? So coastal and marine tourism will be the top ocean economic sector in the ocean economy by 2030, more than oil and gas, more than ports, and it's significant. So more and more, I think that we should use the tourism as a sector to finance conservation action. So also a question that I'd like to pose is, could you use this user fee in MPA tourism to fund short and long-term cost of marine protected area, given that essentially conservation actions have short-term and like establishment cost and long-term cost for like managing it. What we're seeing is like this. So if you put an MPA or if you put a conservation action, biodiversity will increase in time, and willingness to pay of tourists will also increase. And essentially, long-term, yeah, you can use this this tool, the financial aspect of converting willingness to pay into like a financial aspect for supporting your management. But still, it doesn't address the short-term cost of management actions or conservation action. But what we found, again, is that recreational divers are willing to pay $14.53 for the MPA name itself, and the willingness to pay will increase as biological attributes improves. So essentially, instead of that increase from 0, it should be like this. So there's an MPA effect, that the name itself, they're willing to pay. Then as biodiversity improves in time, then the willingness to pay would increase as well. In summary, widespread economic benefits of upgrading the protection status of sites globally, huge opportunity to finance conservation through MPA tourism, and the next step is really using this idea in the real world setting. Thanks.
We do have time for one super quick question, if there's a question, or we can hold them over to the end as well. Oh, Phil.
Were divers the only, were scuba divers the only people in the sample group? Were they only scuba divers? Were they all general reef users?
Good question. Yeah, I don't know. I don't know that. It's mixed. There are snorkelers as well, but we will only interview people that are scuba divers, meaning that has done scuba diving. Okay, all right. So okay, but it's mixed. Okay.
Cool. Okay. Thanks for that. There's some really useful information that would have been very handy through lots of marine park zoning processes in that discussion. Let's just call it an MPA and we can make some money. Would be great. Do we have Nathan here? Yes, there we go. So Nathan's going to be discussing using environmental markets to fund restoration of coastal wetlands and coral reef protection. So over to you. And we'll probably hold questions over there as well.
Thank you for that. Thanks everyone for coming along today. Can I also pay respects for the Indigenous traditional owners of the land that we're meeting on today? I've travelled up from Townsville, so I work and play mostly in the Bindal and Woolgooroogabar land, so just pay respects to elders past and present there. I'd also like to thank the funders as well. This is really a 15-minute journey. We're going to give you an overview of about 8 years of work that we've been really quite excited to share, and then there's still lots of opportunities, I think, to come around this concept of environmental markets. Oh, okay. All my slide hasn't come up, but anyway, we'll keep going. We've heard about the Reef 2050 plan, and there's a real interest in focusing on the Great Barrier Reef and some of the important drivers that are impacting the health and quality of the Great Barrier Reef. I don't work in coral reefs, so I work on these, I guess, more interesting coastal wetland ecosystems along the coast. These are transitional areas, things like salt marsh areas, seagrass, mangroves, palestrine floodplains, lacustrine floodplain areas. And these are the areas really where we've changed and modified these coastal areas to provide services that we expect, I guess, along these areas, as well as recognising a lot of the services that these coastal areas also provide. So just a couple of quick photos. These are some of the pressures that we have along these coastal areas. We have a lot of agricultural development, particularly in the Great Barrier Reef catchment areas. The top photo there is actually a constructed wetland that was built back in the early 1990s. There was vision back then, some 3 or 4 decades ago, around trying to put back some of these environmental values back into the ecosystems there. So that was a wetland that was being built. So we have this expectation in this coastal area that we want to have these services, economic services, for example. But this creates a really interesting conundrum, because we also expect these coastal wetland areas to provide services for environmental outcomes. Commercial values. We also have lots of different interesting species that live along these coastal areas as well, that love to call these places home as well. So we have this challenge between protecting and conserving these important coastal wetland areas, but at the same time we're looking to modify and expand on these areas. So it creates a real challenge. We've heard, I think Cedric did a great job introducing some of the economics around these important market mechanisms that are coming through. And the Australian government really has taken a big interest in fast-tracking, enabling some of these market mechanisms. There's things like the Australian Strategy for Nature that's come through. We've heard a little bit about today, I guess, the nature repair market. Cedric's also talked about the Global Biodiversity Framework, and these are really important international opportunities or drivers that are in place for us to really think about the work that we do in the context of some of the global targets that we have there. Now, there's also barriers to that as well, and Justine Bell-James, who's going to give a plenary tomorrow, looking at some of the legislative barriers. I've heard today already people talking about permits as being a real barrier for upscaling coastal restoration and certainly coral reef restoration as well. So there was a paper published just recently. I think Justine will probably give some more of an overview of that tomorrow. Justine's our resident restoration lawyer that we've got on the team, so we're really lucky to have Justine there. I've mentioned that this is a journey of about 8 years, and I've been very fortunate to work with a whole range of project partners. These are research end users right across the Great Barrier Reef catchment areas. These are traditional owner groups, these are NRM groups, these are landholders, these are government employees, community groups as well, that have a real connection, a real passion for coastal wetlands, for a whole range of services and values that they have. And we've been quite particular in the kinds of science evaluation that we've been looking at across these different types of projects, focusing on some of the real different pressures that are facing these coastal wetland areas. So things like feral pig impacts, water quality issues, invasive weeds, and those sorts of things. And this is a real ecosystem of people that have come together now to really try and protect and promote and restore some of these coastal wetland ecosystems. And we really need that ecosystem of people to come together. I think if we're going to try and get to the scale, I think Cedric mentioned the 30 by 30, the 2030 goals that we have around repairing our lost and damaged ecosystems. So can we afford that? Can we afford to really upscale these coastal wetland restoration projects that we need in place? And the answer is we don't have enough money. Government has been great, been supporting a lot of the great work that we do, but we do really need to upscale this, and this is the theme coming through the talks that we're hearing today. So we do need to look at some of non-traditional ways of funding these kinds of scaled ecosystems projects that we need. So we've been working now for quite a few years at aligning the science that we do with things like blue carbon, with reef credits and biodiversity certificates as well, which is coming through. And can we look at mechanisms of incentivising the kinds of restoration works for these kinds of projects along the coast? I haven't got time to go into a whole lot of detail, but just a couple of quick examples of some projects we've been working on. This is the best wetland in all of the Great Barrier Reef catchments. This is Mungala. This is the Nawagi land country that they have near Ingham. Been working with these guys for about 12 years now. You've got this tragic but wonderful backstory to it. They're very interested in moving away from the traditional applying for grants to do work on their country. That is effective. They're doing some great work, but it also creates a lot of challenges for them. They lose human capital because there's gaps in funding. So as a way of trying to address that, they're really interested in blue carbon as a way of incentivising the work they do, increasing opportunities for financial incomes to keep that project and the work that they want to do in place. This is the first blue carbon project that, in all of Australia, the first blue carbon project where there's a traditional owner group that's going to be driving this forward. And we're almost close now to registering this project with the Clean Energy Regulator, so we're pretty excited about that. In Australia, we have just one approved methodology for blue carbon, and it is around removing tidal barriers and allowing low-lying areas to be reflooded with salt water and transitioning possibly back to sort of marine habitat vegetation. So this is the only method that we have at the moment. There'll be more, I'm sure, coming through in the years to come. We've been really fortunate with working with our good friends, Great Barrier Reef Foundation, to look at a project site with a farmer down near Mackay, where he's very interested in transitioning from the current land use into a blue carbon project. And again, we're almost ready to lodge that project through to the Clean Energy Regulator. I can't give you all the details because there's commercial confidence, right? But yeah, pretty excited to think that we're at that stage. I do have one slight problem with the blue carbon methodology here. If you look at the ponded pasture, that is a freshwater ecosystem. And that freshwater ecosystem has, in its own right, a habitat that's provided for things like freshwater turtles, freshwater crayfish. And so what we're suggesting here in this particular example is we're transitioning from a freshwater habitat, although it's degraded, it's still providing some service. And we're saying now the expectation is we're going to have a blue carbon outcome. So I think, again, there's this trade-off that we really need to think quite carefully about if we're going to be embracing blue carbon methodologies. In saying that, I think where there is a really good opportunity for the blue carbon method to work, and that's in these low-lying sugarcane areas where the country is wanting to revert back to being underwater again. This is our best opportunity that we have. We have, in terms of aquatic biodiversity, quite low, obviously, as opposed to ponded pasture. But I think there is a huge opportunity for us to take these non-productive, low-lying sugarcane areas and turning these into blue carbon projects. And I started talking about this concept back in 2016, and this has been about 8 years now. And I'm quite excited to think that we're kind of really at the point now where a few of these projects are coming online, so this is quite exciting. But what this creates is a challenge for some of our industry partners who are in the business of sugarcane. This is actually not a good outcome for them. They don't want to see lost sugarcane areas. So I think in the words of John Brodie back in 2016, when I started this project or this idea, he said, yeah, great move, Nathan, good work, going to be a great project. Possibly career limiting, though. But here I am, 8 years, still talking about it. We have actually taken this to the point where we've mapped out between about Mossman to Serena, it's a few thousand kilometres of coastline, all the areas that are marginal sugarcane. And we've looked at some of the economics around that, be it for blue carbon, for water quality outcomes there. So we've got all that baseline mapping done. And now we're working with project partners to take this to the next level with some of these sites. And I think there's also a real need for this because this is the real opportunity that these farmers have. This is a screen grab of this particular site with the 2100 flood sea level rise map overlaid. That little yellow dot is where this farm is. And I think there's real opportunity now to take this opportunity to entertain a blue carbon project now. In the future, he might not get that opportunity. So I'm going to show you a little bit of data. And this is all hypothetical. So you can take photos, but I'll deny the numbers later on. This is hypothetical. I want to make a couple of points here. So let's take two of these land use blue carbon scenarios. Let's take the ponded pasture site and the marginal sugarcane site. Let's assume that we have a 250 hectare project using BlueCam. This is our method and model that we have available for us to look at the carbon attenuation opportunity. Over a 25-year period, 67,000 tonnes of carbon. Let's assume the carbon price is $40 a tonne. Now, that's actually a bit higher than, according to Eco Markets Australia's quarterly report last month. It's actually a bit higher than that. Let's assume $40. And if my math is right, the farmer in these scenarios would look to generate about $2.6 million if he was to transition across over 25 years. Now, my ponded pasture A site, let's say the farmer says to me, I'm earning currently $500,000 a year on my property. So entertaining a blue carbon project would actually lead to a net loss of around $10 million over 25 years. It's not a valued proposition for him. If we reverse calculate it, we need to be up around about $190 a tonne for carbon to make this a viable proposition for him. This is excluding any operational costs, reporting costs, all those kinds of things. It's just a hypothetical example. In my second example here with ponded pasture, let's say the farmer's generating about $50,000 per year over 25 years. It's actually a value proposition to take up that $40 a tonne. He'd be actually about a bit over $1 million in front over 25 years. In my sugarcane scenario, now look at the photo. The sugarcane, there's no sugarcane growing on this property. So he's actually earning nothing. In fact, it's probably costing him because he's paying rates, he's probably paying to spray the weeds. So a $40 a tonne for carbon is actually a pretty good proposition over 25 years. He'd earn about $2.5 million. So that's a really good proposition for him. So for fun, let's calculate $186 a tonne. The farmer would earn, over 25 years, about $12.5 million for that project site. He's probably very happy. It's a good proposition for him. Now, this is a hypothetical situation. I'll just remind everyone again of that. This raises two important points. The first point is the land and the land use and the value of that land use, the starting value, is really important. So where we locate our blue carbon project is really, really important. The second thing is to operationalise a restoration project using just blue carbon is not going to be enough. We need to look at bundling additional ecosystem markets together. And this is where our work is currently at. So we're looking at, can we add in green carbon? Can we add in reef credits? Can we also add in biodiversity? And I'll put some asterisks there because that's still coming through. We're still not sure what biodiversity certificates are going to look like. And I think that's what we're going to need to be really focusing on in these next few years if we want to operationalise at scale wetland restoration projects. If the land value and the activities to start with are quite high, we need to really be thinking carefully about that. So we need to start to think about bundling and looking at multiple lines of or pipelines of income to operationalise these restoration projects. And so we've written around this idea of bundling ecosystem services. It also maximises the environmental return, environmental dividend return, water quality outcomes, biodiversity outcomes, carbon outcomes. we have these really wonderful outcomes there. We're investing a lot of time. There's a bunch of us around Australia working on new method developments, and a really exciting one is around feral ungulates. So these are hooved animals, and the impact they're having on our coastal wetlands, and can we actually, by removing these pressures on the landscape, see wetlands for biodiversity, for water quality and carbon outcomes? Can we put some monetary value around that? So my final points are that these are really important coastal ecosystems, these coastal wetlands. They are connected to the Great Barrier Reef in important ways. They have their own rights and values. But to keep them, to protect them, to restore them, it's going to cost us probably a lot of money. Our eco markets, I think, have some promise, but I think we need to be very careful in how we move forward, just going on some of the examples I've got there. And the pilot studies that we've been really fortunate to have funding come through have been really so critical, because that reduces some of the risks on the landholders to pay a lot of money for these kinds of projects and understanding and knowledge that we're generating. So I think we need to be thinking quite carefully about that, particularly when we start to think about bundling these services together. Thank you.
The trend continues, so again, we'll bundle some questions up towards the end. It's a perfect flow of speakers now, because we're actually talking about ensuring sugarcane processes. So just want to bring up Russel Mehmet from Willis Towers Watson. So here we go.
Thank you very much. And as you can see, I'm joined by Peter Thorburn from CSIRO. I know everyone's very excited to hear about insurance, but what you'll be a bit more used to is the agronomy and the science side. So Peter will deal with that to start, and then I'll move on to the insurance side of things. So Peter, over to you to start things off.
Thanks, Russ. I suppose on behalf of the two of us, just acknowledge the traditional owners of this land in which we're meeting, also the lands on which this work was done and to which it's relevant, and the waters that it will have an impact on. Cedric, who's ducked out, did a great job at the beginning of the session talking about the role of market-based instruments like credits or financial instruments like insurance in getting ecological outcomes. And he also then, much to my appreciation, talked about the importance of good science underlying these things. And so my role here is to talk about the science that we've done that's then allowed Russ and his colleagues to create a well-first insurance program based on that. A little bit of background. I think this won't be a surprise to anybody, but lots of water quality is a threat to the reef. The one we're focusing on is dissolved in organic nitrogen. There are a number of proven, land management, farm management, crop management practices to reduce discharge of dissolved in organic nitrogen, but these need to be taken up. And the reef report cards that I think we all know about, show, at best moderate progress towards meeting targets, which is implying that we need some sort of innovation in changing the land management practices. So digging down to the specifics here, nitrogen is critical for crop growth. That's why people put fertilisers on their crops and possibly on their lawns. But the question is, what's the optimum amount of nitrogen fertiliser to apply? And that's actually surprisingly an uncertain, unknown amount. And so how do farmers working with high value crops, and sugarcane in the big picture is a high value crop, manage that risk, that uncertainty? They tend to look to apply high rates of nitrogen. Now this would be fine if you were dealing with something like another nutrient like potassium that has much smaller environmental consequences, But with nitrogen, their risk management strategy has an impact on the environment. So, you know, this provides an opportunity for innovation, the innovation being insurance to manage risk rather than over-application of nitrogen to manage risk. And so we're talking about risk and stuff. We've got to be able to quantify that risk to be able to move up that sort of chain that I've just described. So here's what we've done. I'm not going to go into detail. We have worked out how to quantify the risk that a reduction in nitrogen fertiliser from some high rate to a lower rate will pose to yields at basically a field scale. Now, this is really important because for two reasons. Biophysically, the risk varies from field to field based on the soil type, some of the aspects of the crop management, also the climate. And secondly, anyone who's dealt with farmers, they know their farm and their region at the back of their hand, and they know that this field behaves different to that field behaves different to that. And if you ignore that, if you try to say, you know, the whole of the Mulgrave Valley, everything acts the same, you're sort of dead in the water. So we take the ability to do the analyses at this scale with our AppSim farming systems model, which is the best tool available to represent sugarcane growth as a function of nitrogen application, all those things I've said there, plus lots more. In fact, it's the only tool in the world that's able to do that for sugarcane. And we do that, we look at the risk, which then can be passed on to Russ and his colleagues to turn out premiums. But then you've got to come back a year later and say, oh, well, for the weather that crop experienced, the yield was a yield reduced by the lower nitrogen rate. Of course, it's this weather variability from year to year that actually drives that unpredictability of optimum nitrogen. And so that provides a mechanism for assessing the loss. And Russ will tell you how that actually gets translated into business.
Hopefully. Thanks, Peter. Yeah, so when Peter came to us with the problem of designing a policy under using conventional methods, like your house, you know, the damage happens, the assessor comes out, looks at the damage and makes the payout. We realised that that was just not going to work with what we're talking about, the administration side of handling that, the policing of the amount of nitrogen and the reduced amount of nitrogen from the farmer, the payout, how much yield did he was never going to work. Hence we moved towards what's called the parametric approach, which looks at the data that Peter has modelled through his system and then applying that to the actual climate that has occurred during the previous 12 months to look at, depending on how much the farmer has reduced his nitrogen level, the potential loss of yield, if any, that he's had at the end of the 12 months period. So that's really is an outline. If you go onto the website, the WTW website under nitrogen insurance, that is the basics of how the cover works. It looks fairly complicated, but extremely simple if you put in the information online. So it starts off by the farmer selecting how much he wants to reduce his nitrogen on that top left-hand column. If he reduces it from, say, 6 easy steps, says 160 for that paddock, and he decides, no, I can be more practical and potentially practical if I reduce down to, say, 120 kilograms per tonne, knowing that if he has the insurance, then there is a payout for that loss of yield at the end of the 12 months. So the data, again, Peter went into in detail, the climate, the soil, the crop, works through what the premium is, and the farmer chooses the cost of cane and puts that into the system, and a premium is calculated. If he decides to go ahead and buys for that 24-25 period, he does so, and then at the end of the 25 growing season, the harvest season, he looks at, the system looks at whether a payout, a simulated payout, would have applied based on that 50 years model data, historical data, compared with the past 12 months based on the BOM data. So it's as simple as it gets, and then the outcome is provided to the farmer. We provide that and to the insurer's liberty, and if there's a payout applicable, then the amount is paid within 30 days of that end decision. Now, inclusive with that, with the actual payout, if he did have a yield loss, will be the savings he made in not applying the nitrogen to that particular at the start of that season. So in our example before, 40 kilograms of nitrogen would have been saved, and as it's around twice the price of what it was 2 years ago, that's a significant amount. That covers that. And I think I've jumped ahead a little bit here by sort of explaining the simplicity of the product. On the right-hand side, it shows the data that the farmer puts in, the climate zone, works out where he is. Soil type will come up because he actually, as Peter said, chooses his own, the specific block, so it's very personalised. You look at which month the crop started, the original nitrogen rate, 160 down to 120. The rate there is the premium rate that shows. Gets a block number, the block's area of 10 hectares, and the cost of cane that he wants to use, up to $60 now. So it's all very tailored individually. He looks at each block. It's a question that's come from farmers. How many blocks can we look at? Because as Peter said, they all vary. Blocks can be done individually and are done very quickly. The potential that the saving in the nitrogen can be greater than the actual cost of the insurance is something we've seen quite a few times, so extremely beneficial. And of course, if he's able to reduce his nitrogen level and still receive a yield payout, then the farmer is extremely happy with that situation. So the solution is, very importantly for what we're here for, is that if you comply, first thing he wants to comply with farmer wants to comply with regulations, but at the same time, if he does that and the nitrogen is reduced, then the quality of water is what we're all looking towards. So I've only briefly touched on here, that's the nitrogen product. Insurance has a lot of other potential value, as Cedric would know, because we've talked a bit about this, of various other events that could happen to barrier reefs. Tropical cyclones, sea surface temperature, very topical at the moment, wave height, COTS outbreak, which I hadn't really given thought about, but Cedric said it's all measured, so a massive increase in COTS that could affect the water quality in the barrier reef. The difference in the two at above a certain level would be insurable. That type of thing. Claims payments can be used for any purpose. They're paid within 30 days, available for any purpose that would be suitable to the organising committee or sponsor. A couple of examples that WTW have done has been a Belize Barrier Reef catastrophe wrapper. I think we called it that, but it's to do with finance and the benefits of reducing funding as when a major event, in the case of a cyclone or rainfall in a particular area, hits. And one was just been done very recently, is in the Fiji Coral Reef, where with BHP Foundation, they've been able to support a cyclone, what we call a cat in a circle, cat in a box, cat in a circle. So any cyclone above a certain category within a certain area, the payout's made. So the final slide is in conclusion. It's insurance is always available for something, as you all know, but it's an innovative way and not really thought of for barrier reefs around the world. As Peter said, the Nitrogen Risk Project is the only one of its kind in the world with that sort of data sitting behind it. It can be used for many different areas, land management, water quality, which is in the nitrogen one, and of course for supporting and impacts on communities, on tourism operators. Again, Cedric and I talked about coming together for a mutual for tourism operators where they share in the cost of it and pay out following a big cyclone is paid out to the proportion of what they shared in the cost. is a good way to help regions. Nitrogen we talked about at no public cost. The potential to develop new programs. So anyone who thinks about, oh, wouldn't that be a great idea, parametrics is really open to any thinking, because if it's got the historical data that's robust and well controlled, and there's a good way of measuring it at the end, anything can be designed rather than conventional insurance needing claims assessing and that sort of thing. So finally, the challenge that Peter and I face is getting the word out there. We've talked to government, etc., and to the farmers themselves that it's a novel idea. So they really, getting the awareness and the education to farmers is the big challenge we face for what we hopefully will be beneficial to the reef. That's it. Thank you.
Thank you for that. And I have to say, I was actually involved in the Cat in the Box. I think that's a snappier title than Cat in the Circle, but essentially the Category X cyclone going into the box. So, yeah, so that's great. We do have some time, I think. We do have some questions if we still got the speaker relevant. So there's 2 questions. I'll go Barbara, ladies first.
Hi, really interesting idea. I was wondering if the yield's a bit lower than anticipated, but the model says it's not due to nitrogen, do you have enough trust will farmers trust that outcome if that means they don't get the insurance payout?
Pretty good idea, but I'll let Peter step forward.
So the Rolls-Royce for insurance is that Russ described indemnity insurance. You have a car, it's insured, it's crashed, you can see it's damaged, and all that stuff goes. When we started thinking this through, everyone hates modelling. Any modellers in the room here know that, the only thing hated more than modelling is insurance. Try combining the two. So we looked at what it would take to crack an indemnity product, and it would the overheads would completely kill the concept. So I suppose what we do is talk through with farmers that you're getting a simulation of what's happening on your farm. There are some things that are not included in the simulation, so that the real results might be different. Sometimes that might be in your favour, sometimes it might go against you, but this is the lowest cost way that you're going to get this cover. And it's, for me as a modeller who's spent his life doing agricultural modelling, it's actually quite interesting looking at how this conversation with the farmers changes the way they start looking at the modelling, because all of a sudden an insurance premium becomes a sort of a unified indicator of risk, and they start actually using the product concept as a decision support tool to work out, well, could they explore reduced nitrogen? Like, oh, the premiums here aren't that high. Maybe that's somewhere that I should be paying attention to. Oh, the premiums over here are really high. Oh, that's really risky. I should stay away about it. So it shifts the conversation from how many decimal points of accuracy does your model have compared to the real world, to this more conceptual understanding of the situation and how it happens. It's actually been, quite instructive from that point of view.
Russell, Basil Ayek from AIMS. It strikes me in your commentary there that one of the risks we're running around pilot deployment at the moment is, we go through and we deploy and there's damage done to the reef, and how's that going to be restored, recovered and funded, should that occur? And I wonder whether there's room to innovate in the insurance product of what you're talking about there, to at least share and bear some of the costs of what a repair might look like. So I think it's worth taking that up and talking a bit further.
Yeah, that's great. Arising from a climatic event, a serious...
Well, not necessarily climatic, but also some kind of issue with the deployment. So if the pilot deployment isn't successful and damage is caused into the reef as a result, one of the issues and the risks being run by all the parties considering that is who bears the cost in the World Heritage Area to repair and restore what damage might occur.
Yeah, that's right. yeah, it certainly could be done. Yep.
We've got two more questions at the back.
Yeah, thanks very much. Like, I love that project. I heard that before, and I'm like, this is such a good example from a market-based instrument that seems to work. So great.
Yeah.
I have a question. How do you verify that the farmers actually reduce the nitrogen application, what they say? Is that based on trust?
Trust. Yeah, it's part of the policy, and a couple of other things. They've got to pay the premium for a start, and there's no guarantee that they will have a loss, a yield loss. So if someone's prepared to pay the premium on a chance, that, you know what I mean? It's and there is built into any insurance policy the trust element, the utmost good faith. It's called in insurance. So it's expected that they do it. But there's no audits. The insurers doesn't go out and audit the farmer or anything of that nature.
And is it also a cost saving for not applying that much nitrogen? I have no idea what that costs. So that's another incentive.
So there's no motivation for the farmers.
Yeah.
To pay money to cover the risk from reduced
Very clever.
fertiliser.
That's it.
And then pay for that extra fertiliser.
That's true.
So it's sort of self-regulating in that way.
Yeah.
But the flip side is that if the contractor who's applying the fertiliser makes a mistake, they've got last year's instructions, not this year's instructions, then it's sort of the farmer doesn't necessarily get penalised for that specifically. So there's a peace of mind about it. So that's part of this sort of model-based parametric approach, the swings and roundabouts. Yes, it's possible some person might not reduce their fertiliser, but if that's done, there's no motivation. But if it's an accident, they're not going to get penalised, so they don't have to lose too much sleep over that.
Yeah, the decisions from the model, and the insurer pays on the model. CSIRO's model decision, and that's it for them. Yep.
And we might take one last question on insurance from Myron, though. Who said insurance was boring?
Yeah, who said it's so popular?
So mine wasn't for about insurance, it was for a couple of the earlier speakers. Okay, thanks. Myron Silverpalan from Adaptus. I've got two questions. One's a really easy one for Theresa, and then one for Nathan. So, Theresa, in your presentation, you mentioned that the US market is quite attractive for philanthropic investment. I know ESG as a concept has become a little bit contentious in the political environment there. So just wondering whether that's influenced what you're seeing in terms of flows of funds and capital from the US?
Yeah, I mean, there's absolutely no doubt. I mean, ESG, in all the corporates that we speak to, it's the number one issue that their sustainability teams are dealing with, and particularly around the things that Cedric was talking about, and how do they sort of deal with biodiversity impacts, not only from themselves, but in their supply chain. And so there's a big pull to be seen as being leaders and being ahead of the curve, and so that's driving some of this shift. And I'll just stress that it's not about those partners giving us funds to deliver on their ESG commitments. There's a big line that, that's not a space that we go to at all. It's about them wanting to demonstrate that they're leaders and to get a competitive advantage, particularly from shareholders who are more and more pushing the strong ESG pieces. So they need to do a piece of work for which they get no return back on the ESG side for themselves, but they can say we're investing when we don't need to make the planet a better place. Does that answer the question? Great.
We're going to second question.
Yeah, this is for Nathan. In your 3 case studies, you had the first farmer where the investment case wasn't making sense. Have you investigated, other dimensions of value, co-benefits that may or may not flow directly to the farmer, but it potentially could be sort of characterised and used as part of an investment case that could attract other sources of funding?
We have, yes. Biodiversity, I can address that very quickly. There is no mechanism in place to do that. The government's working hard on that now. So there is a cassowary credit possibly ahead of time, so that might help us there. Yeah. For reef credits, this is a water quality incentive for, I'll talk about intercepting wetlands, to polish water coming off a land use where it has a treatment before it hits receiving waters. The method development for treatment wetlands is so close to being finished. So again, it's almost there, I suppose. This is the excitement, I suppose. Once these mechanisms are coming through, then we need to actually have these projects on site and then start to monitor and evaluate how successful they are. Even with the blue carbon, I didn't quite mention, but there's not one blue carbon method, one blue carbon project in Australia that's actually been approved yet. There's a whole bunch of projects that are sitting there with the Clean Energy Regulator, and some for almost 2 years, some projects for 2 years, not quite there yet. Yeah, I guess it's a case of watch this space.
Okay, I will do a very quick 30-second summary because we need to duck over to see Mary at the next plenary. So I'll just finish by saying it was great that we started with Show Me the Money. So with Cedric's new biodiversity credits and the new approach or potential there, and then Theresa just talking through the dynamic nature that is finding and securing funds outside of something like an ARC grant proposal. It is a complex, complicated process, and things like COVID have mucked the donor corporate world around a lot. So it's a massive state of change now. So show me the money and then follow the money. So the willingness to pay work is just a great example of how you can use that economics to influence policy. I may have used some of Natalie Stokel's earlier liveaboard valuation of shark tourism to great effect in previous roles. And then looking at, you know, the best land use, it's like it's the money. It's the money, stupid. It's like if you can show somebody the benefits, the economic benefits, quite often that's the clincher and changing land use practices, because having stuff that's under the water for most of the year is not a good use for cane or anything like that. So, and then, you know, parametric insurance stuff, it's great. It's a good way in developing countries to get the money where it's needed ASAP at low cost. So you've got 4 minutes to get to the next plenary. So
can I just make a quick response to that, yeah. Jim? It's great, you know, and we're hearing that there's that appetite out there, and we're developing new models that we're going to need, you know, to do all this. But what can we, as strategists and project managers and those sorts of things, do right now so that at our end of things we're preparing ourselves for that environment down the track? And it's disappointing Cedric's not here. I'm sorry to hold everyone up, but I know he talked about area and he talked about complexity and those sorts of things. So, but in a role that you're in, Jim, it'd be a great thing to take into the room and you know, have a bit of thinking at that bottom end.
As everyone runs, I think you should hug your local economist so that we can actually put a value on life below the water, because we don't do that well, and that's why it probably gets the smallest bucket. We just value commercial tuna fisheries in the Pacific. We don't value the coastal fisheries, which actually supply nutrients and, you know, health and education outcomes for local communities and their livelihoods. So, yeah, hug an economist.
Or a square metre of tourism coral.
Yeah. Thanks, everyone. Sorry. Thanks, speakers.